of the 9th edition of XML Prague. Is it better now? Yes. Thank you. Thank you for providing feedback. So we will start today with the presentation of sponsors. And actually, there is only one sponsor who is ready to be presented right now. Oh, sorry, there are two. So let me to invite George Bina to tell you a few words about Oxygen.
Thank you. Good morning.
Morning.
It's great to see you here this morning, and I hope you enjoyed last night the demo jam and the party. We are happy to support XML Prague again this year, and probably will do it also the following years. And XML Prague is the only conference where we bring 6 people to the conference, right? So we find this useful. When we get back, we are ready to work on some new things that we got ideas from here, and we just can't stop to can't wait to start working on new things. I know 2 years ago we introduced the party at the demo jam, the XML dance. Now we are not that brave this time, but when we discussed the brainstorming ideas, Zarela, for instance, said that I was thinking that we were doing it like that, the angle brackets, not like this. So you see, new ideas. Maybe there's time for a new version of the XML dance sometime. Today there will be from the agenda. There are so many interesting sessions, including my session. So I hope you will enjoy that. And yeah, thank you for being here. And one other thing the last thing that I want to say is that you appreciate more this event when you go back, when it's ended. In general, you do not realize, how I always find myself when it's ended, I say, oh, it was so great, I just can't wait to get back. So thank you, and
thank you, George. And let me introduce you, Ron Hitchens from Overstory. I didn't know. And you're also representing Mercator IT. Okay.
Good morning. My name is Ron Hitchens. I'm a founder of Overstory, which is a boutique consultancy that does XML and RESTful services and resource-oriented computing and so on. I used to work at MarkLogic, so we start with MarkLogic, but we work up and down the stack. We do all sorts of things. We're strongly affiliated with Mercator IT. We've both been here for several years now, so you probably know all of us already. The other guys are sleeping off their hangovers because they were out late last night. But they should be here for the break, so say hello upstairs. We have some high-quality pens. So
we didn't drink last night.
Yeah. So we're proud to be sponsors of XML Prague. We'll be back next year, and have a great time.
Thank you.
Cheers.
Thanks.
So now we can start the conference, and you will be.
So we have been a bit faster, but there's probably no reason to wait. So let's start with the first presentation of this morning, which will be given by Charles Greer. Documents and data together again sounds like a great news. Sir?
Good morning. It's nice to see so many people here today on the third day of XML Prague. I remember last year, this spot, Uche had this spot and made everybody sing happy birthday to XML first thing in the morning. And I expect all the gratitude in the world for not forcing you to do that this morning. I'd really like to thank all the sponsors for this event and XML Prague itself. This is my second time I've been here, and it's been absolutely fantastic to finally meet all of the XML people that I've been working remotely for the last 15 years in your community. And it's great to be here in Prague, and I'd like to thank the Czech Republic and the Prague people for hosting us as well, because this is a pretty special place to be able to come. Today I'm talking about documents and data, and specifically I think what I'm talking about is a new capability in technology that we have. I wish it weren't specifically about MarkLogic, but it just so happens that MarkLogic has this new capability of being able to remain an XML document database, but also triple store. We can put RDF into the same database as all the XML and query it together or separately. And frankly, it's somewhat confusing to have all this stuff together in the same database. So this is a speculative paper, and some of it is speculative enough to be outright lies about the capabilities right now. But the idea is to just be provocative and get you thinking about what it might be to have structured RDF data and XML documents all together in the same database. I came to this topic quite a long time ago. Last year I talked about RDF-in-XML as well, but in a more of a systems architecture way. I managed an architecture where we had MarkLogic next to, alongside a triple store, and there were these various methods we used to combine and coordinate the data between the two systems. And it worked very, very well. But I always thought that, even before I worked at MarkLogic, I thought that this XML store would be a great way to store RDF as well, and it would be really intriguing to have the two things together. I also spent a lot of time with language technologies and geography and music as well. So since music is the one thing that doesn't overtly fit into this, I plan to torture you with accordions during the entire talk this morning. This is a picture of my baby that I had to leave at home, a Saltarell button box. So the first thing I want to talk about is just a very loose definition of what a document really is. I know that we could get very formal about it, but frankly, when you've got structured data embedded in documents or structured data sitting alongside documents, it's not all that clear. So what I think of when I think of a document is really something that has a container around it. And I think of a container really as being meant for, if not human consumption, then at least sequential beginning to end consumption. And we all know documents very well, and the fact that they can model very, very rich things is not lost on us. So they're extremely useful for mixed content scenarios where no other solution has really come along to handle the mixed content scenario. And if I think about a few different types of documents that exist, I would consider all of these representations of documents. Even the images themselves could be considered documents, because I could take that as a payload, stick it in the database, and query it, or look for it, search for it. So an envelope might contain a letter that's a document. Legal briefs, Bibles, even JavaDoc is a slightly more rich take on a document, but I'd still say that it's meant for reading rather than for any kind of more random access. And then I have a picture of a flight manual at the bottom, just because it's a very pretty document. And then when I contrast that with data, I'm really talking about this nice slide that everybody likes to bring up, the linked data cloud. This is what we enjoy looking at, slicing and dicing, analyzing, and really enjoying for its own sake. And it's the type of data for which the document boundary is not quite what we're interested in looking at. In fact, it's more interesting perhaps to consider the data that transcends the document boundary. So when I think about data, these are some words that occur to me It might be structured. It's queryable. It's almost always typed. At least I would hope that data is typed. And then it's really what the focus of ETL processes is. If I'm going to bother to extract, transform, and load something, there's going to be a document payload on each side, but probably the very fact that I'm transforming it means that there's something more than just the document structure that I'm curious about. And here are some pictures of data. When I see something that's divided up into pieces, that's an indication that I might be thinking about not just something for reading or mixed content, but there's something beyond that. There's data within there. A graph is certainly a very common use for RDF, and so a graph is data. Any kind of table or entity relationship diagram, or sometimes you just have data and you can't argue with that. So inside of MarkLogic, this is what RDF looks like right now inside of MarkLogic, and you can go download it and start working with it with the Graph Store protocol or with XQuery. There's an XQuery API for manipulating RDF and parsing it. But when it comes right down to it, if I make an XML structure that looks like this, the sem triple, the wrapper doesn't matter, but a sem triple within this namespace is going to have a subject, a predicate, and an object. And anywhere I put this XML into the database, it's going to be indexed with a new special triple index. And I wish I knew where the camera was. I could say hello to John Snelson, who implemented all this stuff, and he must be either asleep or watching from his hotel room right now. So thank you, John, for doing this. You'll notice it's not a standard representation that anybody has seen before, but this is really more for the XML people who can look at this and say, oh yes, I understand what a triple is now. It's got 3 data points. The subject and predicate are always URIs, or IRIs rather, and then the object can be either an IRI or a literal typed value. And anywhere, I can mix this with any kind of content I wish. It doesn't have to be just sem triples elements. I can have a document with all kinds of content and then just inject these wherever I want. The triple index will see it, and I can run Sparkle queries or graph operations upon those triples. So right here, the facts that I have is that my accordion is a button box accordion. It has 2.5 rows of buttons. It has 2 keys. One is the key of C, one's the key of G. And I put a little bit of a label on the key of G so that we can read it in English in this case. So for me, when I think of contrasting a triple store to a document database, I think of taking all of this XML and throwing it into one particular corpus and then doing things with that. I can do full text search very, very easily. I can use XQuery on it. I've got tree structures I can traverse. And then one thing I really always liked about XQuery is it's an application server as well, which is never the case for a triple store. Nobody's built an application server into a triple store at this point. So on the other hand, the triple stores that are out there right now are really all about just storing this particular kind of data. And that, at least at my last organization, that was seen as a fairly big obstacle to adoption of triple stores because you always had to make it RDF first. And there was always a specific purpose for that type of database. But no longer. One thing I've noticed about data is that even though if I take my RDF and put it into a triple store, it's fairly explicitly put into one big bag. The RDF people might use named graphs to distinguish between sets of triples within the triple store, but I think that data really likes to be in documents anyway. Anytime I query a database, I'm going to get out an actual payload, and at that point, it is floating free from where it came from, and you can think of that as a document which contains data. So it's really documents that are involved in things like publication and interchange, and even query results are documents. So data is flowing through and in documents all the time, and I don't want to throw them away. Documents are first-class citizens in an XML database, and I don't want to throw that fact away just because I want structured data that transcends all of the XML documents in there. So what I'll do right now is characterize the different ways in which this document boundary and structured data can interact. And most of it's true even now in MarkLogic right now. And then I'll go on to say how data and documents might be related to each other within the data structure itself. And then I'll just throw out a couple of different scenarios that we've cooked up. One reason it's really nice to get this out in front of you is that we really don't know what the use cases are for this type of data yet. We know that it's great to have XML documents and it's great to have triples in the same database, but as far as mixing and matching, it really opens up some interesting capabilities that we'd like to explore. So here's my first convoluted slide. You've got to throw in a convoluted slide, at least. In brackets, I've got two different documents, each with one fact in them. One of the facts is that there's a patient who is diagnosed with high cholesterol. And that's represented vertically here, the brackets. And there's another document that says that hypercholesterol is a hereditary disease. And because these are two separate documents, we have security that we can apply already on these triples, which is something that's missing from most triple stores. But if I keep that document boundary and respect it, I can put different permissions on whatever triples I want. So if I run a Sparkle query against this database, and I'm the doctor, I can see information about the patient, but I can also have a publicly available data set for things that don't contain confidential records. So the security layer, you just get that for free. You don't have to do anything else to your XML database in order to overlay a security model on top of your triple store. Something else you can do is if you imagine a workflow where you have an accordion factory, you might take orders for accordions in one system. It occurs to me that probably most accordion factories are small enough so that they're not thinking about triple stores, but we'll assume that there's one gigantic one. All of you need at least one accordion, and so there's thousands on order, thousands under construction, and millions that have been sold. And each of these might be stored in an XML database in a directory structure. So I can actually feed in this case, a CTS directory query, and it'll filter all of the documents first before running the Sparkle query. So this is a way where I can provide context to a single type of query and just decide I'm only going to operate on certain parts of the database. And this could be a full text search to partition the database. It could be a directory query or any other kind of operation that I can do on XML. This is probably I have the complex slide, the silly slide, and the kind of slide that doesn't make a lot of sense, but bear with me. I like to think of documents as a very convenient state holder. So if I have a process where I'm going to have a valid state from 2002 to 2010, either insert a new document with some metadata on it to say the validity of a particular document or replace it. But I can have a whole series of documents which are distinguished by properties. And I can use those properties also to partition the database and decide that I'm going to, say, have a bitemporal scenario where I don't have to go around and monkey with my Sparkle queries in order to pay attention to temporal information. I can do that beforehand with a contextual XML-based query. So I'll go from here and think, well, okay, that's all pretty cool. But there's also the possibility of mixing and matching the data and the XML structure in various ways. So in this case, I've got a paragraph and a footnote, and then an out-of-line information about that document. And then right after the document, I have a little bit of more structured data. Bandonio number 4288 is a certain size and is associated with Astor Piazzolla. So in this case, I've got one place where the structured data is marked up inline, another one where it's just a sidecar off to the side. And so the inline method is one first way that I might be able to mix the structured data and XML data. So RDFa, microdata, and schema.org are all ways to do this, where I have positional structured data scattered throughout the XML, and from the context I know that I should be able to query with Sparkle the data which is implicit or which is explicitly marked up throughout the document. Now, this we don't do right now, but everybody thinks it would be pretty neat to take an RDFA marked up document, just insert it into the database and be able to query it right away. Right now we have to parse it and create the XML structures that you've seen before, but this type of thing is definitely on the roadmap. Here's just a picture I found of some inline markup that I thought was a nice way to understand inline markup. And then here's the diagram of where you might indicate the structured data that is throughout your markup. It gets extracted by the triple index. It gets indexed with the triple index, and then you can query it right away within the content. Another way I might be thinking is, I don't know what this is about, but the idea when I see this, it's just a mess of text, but it looks as though there's some other publication going on here, that I've got a document, but really I'm presenting a data set as well. And so I have the possibility of a new publication container where I have a whole bunch of pros describing what my data is, and then the data is right there in the document as well. And so this is a way that, that people who are publishing data-heavy research can wrap their data and their document up together, and it can be published into the world and managed in one place, and you don't need to worry about provenance problems when you're pulling the data out and using it for some other purpose, because it's always going to ride along with the original document. A third way, of course, is a more typical way of thinking of structured data and documents, and that is where you have two different views, two different documents, and one is referencing the other. So I might have a whole bunch of documents in my database, and then a whole bunch of triples that I'm managing in some other way, and they have references to the documents. So I just have the CRUD operations on the XML documents, and then another process which might have triples, and I can just reference them together within the same database. If I call fndoc on URI, I can get back the results of that from a Sparkle query. I can get back the document inline and the results of the Sparkle query this way. So when I think about what I might use the documents for then, it's really that we know well how to manage dependencies between XML documents. This is a well-known technique. And then the documents can also be the scope and a way to partition the database. One possible way I might use this is for rule-based inferencing. I've got a few triples over here about my button box again. It's got a certain wood finish, and then a couple different ways of labeling it. A button box is a class, and its label is button box. And then I've got another type of accordion, a melodian, which is a label of melodian. Well, it turns out these are the same thing. So I've got one document with the turtle on the left, another document which has ontological information which says that button boxes and melodians are really exactly the same thing. And then I've got a Sparkle construct query which says that if I find this triple pattern with the equivalent class, and I find an instance of class 1, I'm going to add another triple, this one down here, which says that any instance of class 1 is also an instance of class 2. Since I'm in a document database scenario, I can manage these all separately, and I don't have to have an external application to decide what the relationship is between all of the different triples. I can mark the first set as inferred. I can mark the ontology triples as an ontological document. I could store I suppose I could store the construct query somewhere too. And then I can have a document containing all the inferred triples. So I know if anything changes in the asserted triples, I can have document dependencies and blow away the inferred ones and run the process again. That's one type of data pipeline, but that's a generalizable thing I can do. Entity extraction is something people are very interested in. We saw a talk yesterday about entity extraction with ontological information. So if I've got this turtle, I think I probably see something different than you do when I look at this. But what I'm saying here is I've got several different classes of accordions, a single row Cajun accordion, a couple row button box, a 3-row Tex-Mex accordion. And then I want to use, each of these have some tags. So the tags, button box, diatonic accordion, melodian, Cajun box, Tex-Mex accordion, these are things I'm going to search for in text. So if I have a document that looks like this on the left, the Cajun accordion is still played in Louisiana, I can do a word search for the tags, and then I can generate annotations based on that search, and then store the results as another document. So this is a way where we can, within one database, do all of the entity extraction and taxonomy management that we'd like to do. And then the last scenario that I'd really like to bring up was something that hadn't occurred to me until I ran into a bunch of Java enthusiasts who, they really like their data binding. They really want a Java object, and they want to think in Java and really have the persistence layer be completely invisible to them. So it's already well understood how to map Java objects to XML, and the XML database is a great backend for this. But now, if we just think of it as another annotation we can put on here, we could add class information. We can add RDF right into the mapping as well. And then all of a sudden, your Java objects are not just isolated. They're within an RDF ecosystem where you can query for them and then return them as documents and just serialize them out as part of a simple Sparkle query. So here's a Sparkle query which is going to ask for every kind of, for every button box that I have in the database, and it's going to be returned as XML for the reverse process of marshaling it back into Java objects. So this is a way where you can write new data access layers using Sparkle or using RDF strategies, and yet also satisfy the Java people who really just want to think in plain old Java objects. And I think this is a compelling reason to provide new kinds of data access without forcing anyone to really go RDF all the way. So those are the three scenarios I've come up with, and then I'd really just like to open it up to see what kinds of questions and holes I've got in my reasoning.
Thank you, Charles. Mm-hmm. We have enough time for questions. We even have mics for questions.
Good morning, Liam Quinn, World Wide Web Consortium. This is one of the first talks on RDF that I've seen that talks about partitioning and context and security. And I'd be interested to hear your thoughts also about how this relates to implementing social systems with privacy.
Session systems with privacy?
With privacy, yeah.
Well, it's fairly analogous, isn't it? I suppose that the point is simply that the RDF people, linked data people in particular, are very focused on opening up everything, and security is a secondary concern. But in the XML database world, security has been a very, very upfront topic. And the fact that we can mix and match these now, it doesn't mean that it's the perfect solution for managing security concerns, but it does mean that we have the tools available already, and we don't have to go any bit further. I'm not sure whether that speaks exactly to the privacy question, but I'm probably not all that familiar with it either. Okay.
It's a bit of a related question, but I think in your scenario you say I have the security when in the database, but one intriguing promise of linked data is that the data can just sit anywhere. So I guess in your scenario you would not say I import the whole of DBpedia. You would rather just use the endpoint of DBpedia to query something, put the query result in the database, and then you have the small set. But that means that if you do it that way, you won't have security because the DBpedia data is maintained by somebody else. So I see you solve the security problem for the data which is inside you, but for this promises, I'm using data just somewhere. Do you have your vision of how to solve that there? Because
well, I think that you've uncovered a bias that I have, and that is that I think that this type of solution is really good for a business and enterprise situation where we don't have federated query. I haven't been thinking about federated query. So in order to run a Sparkle query against an RDF, it's all going to have to be in the same data store for now. So I am thinking of an ETL scenario where you decide what security you're applying to the data you bring in, and then run your queries based on that. But I think that it still holds, even in a federated situation, the idea still holds because my data that I've got here is going to have one security context, and then data out on the web I'm querying is going to have a more open one, obviously. So it still will work. It's just that the external data is very, very open from the get-go.
I have one more question, which is related to...
It's John Snelson, RightLogic. I just wanted to speak to the idea of security and privacy. What we found in RightLogic is that there's a very powerful paradigm where you can kind of query for the set of triples that you want to look at, and then do a Sparkle query restricted to just those queries. And so security is just one instance of that, so as a solution to that problem. Now, of course, if you look at something like Google+, where they have the circles and you share certain information with certain circles, that's obviously another instance of exactly the same problem. And at least for us, we'd solve it in the same way.
I think there's one over here.
This will probably be the last question.
Hi, it's just a very quick question. There was a little note you put early on in your slides just saying, I know it's not RDF-XML, but here it is. Is there any reason why you didn't use RDF-XML apart from the fact that the syntax is absolutely abysmal?
I think you just answered the question.
Right. Just checking.
The syntax is abysmal, but more importantly, it's difficult to index. We would have to parse that into something else in order to make it sense for the triple store anyway, whereas the XML structure that we have maps very directly to the index, and it's simple for people who. I also think it's nice to avoid RDF-XML just because it's kind of a bad word. Absolutely, and we do parse it. We can import. He was asking if it was a standard that we intend to support, and yes, but it's a parsed data structure. Just like we can parse turtle and triples and whatever, but that's something we're going to parse and put into the internal format for now. The hope is that we'll be able to parse some of those and just insert it directly into the index without having to write out some other XML, but this is the intermediate strategy.
Thanks. Thank you.
Thank you.
Thank you, Charles. So let's move on. The next speaker is Alex Milovsky. So hopefully we will see more shadow dogs today. Perhaps a presentation about scientific computing in the open web platform.
Perfect. I just discovered this morning that when I turn off my light, that's bad. When I turn off the light in my room, the power goes out on the plug. So my laptop's not charged. It's wonderful. You go in the pocket. All right. It's the CSS blank tag, okay? Just in case you're slow this morning. All right. This is an extract from my dissertation research with Henry Thompson. He's my advisor. I've been at this for a while. The paper I wrote is fairly dense. The slides are fairly dense. Well, okay. Let's see if that works. Okay. Lower. All right. I can't do that. Here, how about that? Is that better? Yeah. Yeah? All right. Perfect. I've now mastered mics. And I tend to talk fast. So I've got dense slides. I talk fast. Let's go. So the Open Web Platform. You may have heard this term, you may have not. It's like a rebranding of the web browser. But I think it's a good idea because people don't think of the web browser as a platform, as a tool that you can use in other contexts. What the Open Web Platform really means is sort of that we take all these bits. We take the recommendations, the standards, the notes, algorithms, implementations, all these shared expectations. We treat them as a contract between the developers and authors. Right? That's the platform. And my fundamental question in my research was, okay, but why isn't there more scientific data on the web? Why don't we have access in the same way that we have access to other kinds of information, social networks, Twitter feeds, all these things? We don't have that kind of data. It's you go there, you get find some giant tarball of some stuff. Or does the web work for that? So, I did a bunch of research on this, and I played around with different things. This is a wonderful pie chart of data that's stored at data.gov. It's a metadata repository. It points off into all of these different places in the US that have, the EPA, the NOAA, the National Weather Service that have data. And I specifically looked at geospatial data because it's easy to sort of equate that with something that might be scientific. And there's all kinds of things in here. You probably may not be able to read it because it's an image. But this part and this part are about 67% of the data, and that is tabular, right? It's either directly tabular data or it's vector data that contains tabular data. So there's scientists like to produce tables of data that are weakly related to each other. It's tables, reams after reams of tables of numbers, and they mean something. But the formats they use to distribute this information, they often predate the web. There are things that are proprietary formats like ESRI shapefiles. They don't work within the browser. They're FITS images. FITS images are a bunch of image data and huge tables of data stuck into an image format. They have archives of these things, but they're too large to be processed. If you go and look at the Sloan Digital Sky Survey, it's astronomers, it's a terabyte zip file, right? That's what you go download our data, terabyte. That'll take a while. And then who knows what it is, because they don't really tell you until you download it. So it's a real problem. These things are not on the web. And what I want to be able to do is, within the Open Web Platform, poke at this data, explore it. Henry's term for this is paddle around in the data, right? I like that. So I'm going to change the paradigm here. I want to have a methodology for getting data out onto the web. We want it to be accessible. We want to use web-oriented formats. We have tabular data. I've seen a lot of XML that looks just like an HTML table. Why do we have the same markup, slightly different over and over again? So why can't I use HTML tables? Well, there's lots of problems there. And people don't name stuff with URIs. They don't actually give you a constant, stable URI for something. The URI is a mechanism for downloading the data. So we like to name things on the web, make them identifiable so we can retrieve them, we can do stuff and make assertions about them. We need to name things. And you might be wondering at an XML conference, well, we should just be using XML. Why aren't we? Well, people have done that. Astronomers, interestingly, after doing the research here, have been using XML since day one, actually before that. And they've been using it for exchanging data. And they have a thing called VO table, and that is a almost copy of the HTML table model in their own namespace. And it has sort of worked for them, but it only really works in the sense of like tool-to-tool exchange. So when you hit one of these services and you bring it up in the browser, you don't get anything really useful that you as a random, say, amateur astronomer can use. And that's a real problem. You're not enabling people to do things with the data unless they have big infrastructure. So we have some problems here, right? What are the problems? Well, data's too big, right? Real data sets, they're too big to actually operate on within the Open Web Platform. They'll make your browser crash. So we need to solve that problem somehow. We don't have enough semantics. Scientific data, generally, there's things like, here's temperature that I measured in a particular way using a particular unit of measure. I have the error for statistical error for that. You have all this metadata around these numbers that are in these tables. And you don't really have that ability directly in HTML. And then there's this question, this particular viewpoint on this, but we have some of these services like the IVA astronomer cone search services. You create this big URI and you can get a piece of data back in XML. But formulating that URI is not so easy, and it also is sort of a temporal thing. It's not like that's a thing that I can name and then use in the future. How much I get back is limited. So this process of constructing names is very different from service to service, and it's very temporal in the sense that I can't get that, or maybe I have to page, or I don't know how much data I'm going to get back. So we have these three little pig problems. So this is my solution to this, and I call it PAN methodology for partition, annotate, and name. So we're going to partition the data, and we're going to figure out how to do that using properties of the data to create web-sized chunks. We'll talk a little bit about what that is. We want to annotate the data. So I want to be able to use a common syntax of the web, something that is already there, which happens to be HTML. That works really well in the browser, but it doesn't have the things we need. So we're going to add to it RDFa. And then we're going to name things, right? We're going to use the web architecture, the way it has been described as the preferable methods of naming things on the web. You can go read this document. It's a W3C document called The Architecture of the Web, Volume 1. And it talks about naming and good mechanisms for naming. And you might think, well, that doesn't seem really overly complicated, but simple is good, right? We like simple. And people don't, in these communities, they don't think about data this way, right? They're thinking about, I'm going to make a query, and that query is going to return some amount of data, and maybe I have to page that, so they don't think about partitioning in advance. But there are choices you have to make, and that's sometimes hard. They don't necessarily annotate. The astronomers did a little bit of experimentation with that. It didn't really take off. So this is new. What do we do with that? Whose ontology do we use? And there's some good work in that. NASA did a whole ontology for quantities and units of measure. Fantastic stuff. Really well, a good proposal, but I don't think anybody's using it yet. And then, of course, when you have fixed partitioning, you have to have stable URIs. There's a whole, there's a whole aspect of that as well. So what I mean by partitions? It's awful small. You can't see any of that, can you? Let's try blowing it up. How's that? A little better. So a lot of these data sets, like the stuff I'm going to show you in a bit, it's time series geospatial data, right? So we have these different natural dimensions of location and time. And you can think of this large data set as being chopped up into little pieces along those dimensions. We carve out spaces that there might be data. So these boxes could or could not be filled with data, right? You could make a sort of pick a coordinate in space and time, and you might not have data, right? And you may have data. So those partitions, are sort of dependent on your data. But we're going to give them all names. They are all addressable, right? Whatever scheme you come up with, naming your partitions, you're going to be able to address all of these things regardless of how much data is actually there. Now, it might seem kind of silly, but it's actually really good for open-ended time series data. It makes a uniform architecture, and there are ways to basically produce marginals, summaries, that tell you where there is data. So for example, an astronomy service might say, I have this particular region of the sky, and I have data for these things, and I have this much data within each of the partitions. So those kinds of marginals are very useful. I think I need to make this smaller again. Yes. So what do I mean by annotations? RDFa. There you go, right? In HTML, it can get a little verbose, but it's useful. And the main event for me is this HTML table. We have tabular data. We have the HTML table. What are we going to do about adding to that the semantics that we need? Well, I took a partial annotation model here. I don't want to mark up every single table cell because that would be a lot of extra stuff in there. So taking, sort of doing similar things to what the IVA did, the Astronomers Standards Organization. They just talk about the columns of data. They just describe the header of the table. So here we have a table head. We're describing a single column in this table. It happens to be air temperature. Here's the NASA QDOT stuff. There's thermodynamic temperature in Celsius. There's a data type, so in the programming language, you know it's a double. There's the symbol for Celsius, etc. So I have a bunch of information about that. But the location, right, in this table, this needs to be very regular. The location in the header is the same location that in a particular role. So I can look at this thing and go, oh, the fourth column is air temperature, and here's the fourth column in the row, and it's 22.2 degrees Celsius, right? And I know that it's Celsius by looking at that table header and lining things up, right? Not generally rocket science, but it's a partial model. If you get the RDF out of this, you're not going to have any of your data, just the metadata about the table. But we can annotate all kinds of things in that partition. One of the really useful things is links. So this is a link with a lot of information packed in it. It's a link to a partition that's nearby. So in that picture that I showed you of all the boxes, right, it's the web. So partitions can link to each other, and that's a really useful feature. Well, how do they do that? How do I know what's that thing's a link? Well, we have to type it, type of partition. We have to assert some information about that partition. Now, this one is a nearby partition. So these two giant pieces of spans tell me that this is, in fact, a different quadrangle. That's the top one. It's geoshape of a schema box. I'm using schema.org stuff there. And then down below here is the time period that it's for. So it's from these two different times and, on the 12th, and the period of time is 30 minutes. And this information gives me some aspect of those facet dimensions. Now, the facet property in both of these things is telling me something about these partition properties that I picked out. How did I partition my data? So there's a little bit of cart before the horse here in the sense that if you're processing a particular kind of data, you need to know how it was partitioned. Right? There's some extra sort of metadata there. You know which choices you made. So latitude and longitude and time is the way I'm partitioning this. So I've actually done this. I've used it. You can't see that picture in the bottom, but I'll start with the top. So I actually found some good time series geospatial data called the Citizen Weather Observation Program. It's people who have weather stations. I put one up in my backyard to test this. And they spit out data onto the web. And what they spit out is this. It's some crazy ham radio protocol from back in the day that they put on the internet using their own home-cooked peer-to-peer system. It's weird, and I take that and turn it into something else, XML, go figure. But I get about 53 million weather reports a month. Generates 12 gigabytes of data per month. And let me just zoom this up, make my plug for MarkLogic here. I don't work for them, I'm just a groupie. But I take this stuff off this crazy APRS wire, turn it into XML, use XProc, stick it into MarkLogic, use all the geospatial features, and I use XProc to get it out and turn it into web pages and to serve up all that data. Works really well. XProc and MarkLogic get along quite well. So, there's an aspect of this that, why would I be using HTML with RDFa to do this? And I think the aspect, well, the thing that strikes me, and I'm going to show you an example here. It's just loaded. The data has a duality. It is a web page. There's a nice visualization of the weather in the Bay Area right now, I think. No, actually on the 12th when I wrote this. And if you scroll down, there's a giant table of data. There's all the weather reports. But that visualization was generated by looking at the page. So the page is looking at itself and generating the map and plotting, putting all of the temperature and coloring it. And there's a little statistical thing up there about the temperature. All that's generated dynamically on the client by looking at it, the document itself, and where is the data, right? It's not in JSON, it's not in some other format, it's just in that HTML table. I'm looking at the annotations, and I prove that there's some annotations in here if you really want to. Go to the console, and I'm going to just document data, graph, toString. There's a bunch of RDF triples, and I can't even read it here, so don't even try it. But they just goes, It goes on and 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 on. There's a lot of metadata in here, and there's a lot of all that information about the table columns as well. So this is just a simple example of the page. It's just a regular web page, but it's also data, right? I can do something with it. You see one example of that there, and we're going to do more with that. We don't use JSON, we don't do all that. Good. So I have these partitions. I have web pages. What can I do with them? Well, this is where the sort of you need to get creative with your partitioning and what you do with them and your naming. So I came up with this idea of sequence numbers. Basically, you partition the world into quadrangles, and you just number them. And they have, start at the top, all the way around, counting. They have a nice property that you can calculate, use this nice formula to generate the sequence number from a location. And the other nice property is that if you have some kind of polygon that you're trying to, some area you're interested in computing something for, you can take the bounding box of that, and you can generate the sequence numbers that are going to cover that of the quadrangles that you need. And if, in my case, the way I did this, sequence numbers are embedded in that URI. They're a piece that I put into the URI, and so I can use those things to generate the URI of the partitions that I need to start with. So I take the sort of one extreme end of the time period I'm interested in, take the set of sequence numbers, and I can generate a set of partitions. Well, I have links in these pages, right? So I can look at those links, and I can go backwards and forwards in time. So you can sort of create a backtracking algorithm where you start with one set of partitions, and then you just follow the previous links until you've gone to the end of the time period you're interested in. It makes a nice, efficient way of traversing these data partitions. So you have a basis for good algorithms. So when we get to those partitions and we want to do that, how do we find the data? Well, obviously we write some JavaScript, because that's what we do on the web. We write piles of JavaScript. And there's an API for RDFa. It's now published as a note. They didn't want to make it a rec for one reason or another. It's OK. I added some things to it that you need. So someday we'll have an official API, I think. And what you do, basically, is you have the annotation graph and you have the document. Well, every triple in that annotation graph has a location in this document. And so you can go into the annotation graph and find something, and then go to the location in the document and find something, and go back and forth. So if I want to find the table of data, I go into the annotation graph, I find the things that are typed of partition, and then I find the location of that. Well, that's the partition in the web page. I use the subject of that to find the item. In my ontology, I have an item thing that points to something that's in the partition, which happens to be a table. So now I have the subject of the table, and then I find the location of that subject in the document, and now I have the HTML table element that I need to process. And so I do a lot of this. I go back and forth between the annotation graph and the document using the JavaScript API. I showed this, some versions of that for other purposes last year in the talk that I gave as well. Hopefully it makes more sense this year. And it looks like this, and we're going to skip this slide, but those 3 steps are 3 steps and 3 lines in JavaScript. When you want to find the column, it's a few more lines of things, and you can find the index of the column in the table. We're going to skip that slide for now. So we can process data. Now we can traverse the partitions. We can do things with it. So what will we do? Well, we're going to do MapReduce, because MapReduce is what people like to do with big data. So what we're doing is we're taking the partitions, and we're processing them. We're treating them as the resource that we're processing. We're turning that into some resultant. We're applying a function to the partition, generally speaking, to the document. And we're getting a resultant, whatever we want it to be. And then we're reducing those resultants, right? So that's general MapReduce process. But we're going to do all of this in the browser, right? And the interesting thing about this is that because we have stable partitions, we have stable names, we generally have resized the partition to something that is processable in the browser, we're not going to get stuck We're not going to produce, run a query that gets too much data and then we crash and burn. Or we're not going to get stuck behind the next request because we have to page, right? We can do this in parallel. We can use whatever parallelism the platform is going to give us, which isn't a lot, right? There's only one thread in JavaScript, but we can interleave things and it works okay. Is that what's really next? Oh, yeah, so here's my math slide. So we're going to do something real. There's this thing called Barnes interpolation. It's a climate scientist of sorts. They didn't call themselves that. Back in the 60s, named Barnes, came up with this. It's an interpolation process means that given a small set of values, I'm going to generate a bigger set of values, right? So if I have a set of weather observations like temperature for discrete locations, and I want to get a bunch, sort of assume what the temperature might be elsewhere where I don't have a weather station, that's what you use this interpolation process for that. It's a weighted average. And the weights are based on distance. They get recalculated at each stage, and you just basically iterate until you are within some tolerance of your observed values. So you apply this some number of times. It turns out that you need about 3 iterations and you're done. So what does it produce? It's the typical thing you see on the news, the nice, sort of temperature gradient colored on your map, right? That's what they'd use this for. He did this back in the early 60s on an IBM mainframe. We should be able to do it in the browser. And the process looks something like this, the map reduce process. We take a region of the world that we're interested in for a time period. We have this theoretical set of partitions, right? So we process these by traversing them. We get a grid average, a sparse grid of observed values in, the average of the observed values within that grid. So what I mean by a grid is that we're going to divide this space into something like if we are processing a 10 degree by 10 degree quadrangle, we might divide that into 1 degree squares or 1/10 of a degree squares. Right? And then whatever occurs in those little squares, we're going to take the average of. We get a sparse grid. And then we run the interpolation process, and we have filled that grid up with numbers. And then we do something with it. We turn it into a picture, which we can do. We're going to do that right now. So here I've selected the Czech Republic here, right around us, basically. That's not the whole Czech Republic. I'm going to use a 1/10 of a degree. It's for this morning, a little bit. We're going to use 30 minutes duration. That will pull one slice. One set of partitions for that area. We're going to color it from -10 degrees Celsius to 37. And we're going to use 2.5 degree partitions. And we'll just hit calculate and see what happens. All right, done. So what happened, right? If you want to see, there's the picture. You can kind of see the little grid lines in here. And you can do it on the map. I can't really see the map that well, I guess, but there it is. Well, we retrieved the partitions. There are, let's see, 4 of them? No, there's more. There's more than 4, but there's 4 there. I do 4 at once, so 4, 5, 6, some more of them. Each of these partitions, I've packed into the URI. This is the naming part, right? The 2.5 here is let me blow that up. You see that? My slides are obviously not meant to do that. 2.5 degrees, I put that in there. This is the sequence number. There's a date time here, it's tacked on the end. All this information about that partition metadata is packed into the URI. There's a regular way for formulating that. So when I get my sequence numbers and I know the start period, I formulate this URI start there, and then I can follow the previous links backwards. It's very short, and then it was 1.2 seconds to do that. What happened? Well, it loaded an XHTML document, did all the RDFA processing to make the triples available, and did that back and forth, and found the temperature column, and then processed it, and generated the sparse grid, and did all of that in 1.5 seconds from XHTML data. It's very tractable, right? It is completely reasonable to do this with XHTML and RDFA. You could substitute XHTML with XML and random choice of yours. It's going to give you the same metric, right? Because the time occurred is to navigate, via your scripting language, in this case JavaScript, to navigate between the annotation graph and the markup. So my choice of markup is just because I can go to that partition page and view it, right? I don't have to have special software. The browser does it. It does something useful for the random consumer. Well, so you can actually scale this up. Now let me close this for now. So here is the polar vortex, favorite word right now. On January 23rd, for the whole United States, purple is really cold. Purple is like minus 20 or 30, actually more like minus 30 Celsius. So like up in Minnesota, where I'm from originally, people living in my hometown, minus 30 Celsius, right? This is the polar vortex that's been taking over the United States. This took 22 seconds to render in the browser. It's 240 partitions. It's a quarter-degree grid. So it's very tractable. Right? You can actually do this in the browser. So, would you do this as a scientist? Well, I can run headless browsers now. So I can take things like Phantom.js and run WebKit, what's inside Safari, from the command line and generate this picture if I want to. And so I did some of this. I didn't use Phantom.js. I just sat in front of my browser and ran it several times. We can animate that. So here's the polar vortex for the whole of January. The data here was generated by processing all those XHTML pages, loading all that data. It was, I did it for every day, I did it every 4 hours for a 30-minute period. So these are 30-minute snapshots every 4 hours over the whole period of January. I find out interesting things about this, like the browser eventually slows down, right? It leaks memory like you wouldn't believe. So, eventually, if you don't, on my older laptop, I kind of had to close the window and open it again after doing this n number of times. On my new laptop, I have a lot more memory. It doesn't do that. So this is network bound, right? So the data access is the biggest part of that. So 2 minutes, all right. Good, because that'll just keep going. Because this is my last slide. I did it. So why would you want to do this? Well, because people can just look at what I did. They can open up the browser and do view source and go, here's the JavaScript that did it, and there's what the markup looks like, and I can do this for myself. And this code, Henry keeps telling me that this is Tim Berners-Lee says this. Can't find this anywhere, right? But I like it, right? Can't underestimate the power of view source. You can just look at what you did. It's open. It's there. It's available. Copy it. So I call it copy and modify. Took your stuff, tweaked it to do what I wanted to do, right? Now it does good things for me, right? And this lets good constructs go viral. Bad things go viral as well, but whatever. But it enables a hacker in the corner to do something good with data. We want them to do that with scientific data, right? We want to lower the cost of doing this. We want to enable citizen scientists, all kinds of good things. So that's the point. And I'm done. This is water, right?
Thank you. Thanks, Alex. And I can see you want to raise a hand. Michael.
Thank you very much, Alex. Very interesting. 2 questions, I think. You may have addressed either or both of them, but you were going kind of fast sometimes. So when you did your search,
yes.
When you did the live demo, you had a sort of standard search interface. What do you do if the user selects values that don't correspond to the partitions that you've made? Are you partitioning dynamically, or?
Well, in my case, it's a time series. It's time series data. And you can ask for things that don't exist, and you'll get a table with nothing in it. You always get a response from my particular system. I've designed it that way. Okay. Right? But you could ask for nonsense, and then it's just going to halt and catch fire in some way. Like you could ask for a location, values of, locations that don't exist. 500 degrees latitude. That won't work.
Okay.
Right? You're not going to get a result for that. That's a bad request. 400.
When I think about how to apply this to projects I'm working on, I realize there seems to be one crucial difference. I have been thinking, encouraged by the other people in the projects, that what they are looking for are very special cases, and we may need sort of arbitrarily complicated queries. Rectangular slices seem not to be quite the way to do this. To apply it to your case, I'm imagining how would this work in the case where someone studying the weather data says, no, I really need to look at just those days when northern Arizona is colder than southern Illinois. Does that map to your model at all, or is that a different problem to which this is not a direct solution?
Well, the process of getting the right partitions is there's a whole another layer here of the geospatial computations, right? If I have some random polygon, right, and I want to know what data is inside that, once I get the partitions back, I have to then go, is this piece of data in the polygon that I'm interested in? So that's a problem, but that's a geospatial computation problem that every system has. And all I'm saying is that you can get coverage, and then you have to compute that, right? So if you're saying compare region X to region Y, you have two polygons. You have to cover them, get the data, find the ones that are inside the polygons, and then do your computation, which happens a lot anyways. You know, if you're the astronomers have this problem too. You can say, give me all the data in this cone. You're going to get lots of data you don't want, and then you have to filter it somehow.
Okay, so your model is the partitions is the first step. You bound it so that you need to transfer a minimum amount of data, and then you will have arbitrarily complicated querying and filtering happening in the browser. Right. And that's just the second stage. Is so that?
Right. The fundamental problem right now is access to data. We don't have data on the web. So the idea of the methodology is we provide this. Now, if you're trying to do high-performance modeling of hurricanes and stuff like that, you're going to have to take the data out of this system, put it into your high-performance grid thing, and run your simulation, right? People do all that already. That's the high end of computation. You just saw the other end of it in the browser. So there's a spectrum here. I'm trying to sort of get the middle to bottom spectrum solved. Because the big guys already have money and time and systems.
Okay, thank you. So thank you, Alex. We need to continue with the next presentation. And the next presenter is Jonathan Roby, who will talk about RESTful API description language named Radl.
Oh, look at that. I walked off with it. I'm still thinking. So that conversation was just...
Okay, can you hear me? Okay, thank you. One request, if people start talking in Twitter about whether I'm talking too fast or swallowing my consonants, please just say something and I'll try to speak out. I'm going to be talking about. Oh,
you have done something with.
Oh, I'm sorry. I seem to have lost my screen.
You should do mirror displays or something like that.
Let me keep that in correctly.
Yeah, mirror. Yeah.
Okay, good. Sorry about that.
Click on the dialog box saying that you want to mirror devices, which is.
I think that I got that now. Oh, okay. Yes. Yeah. I've got it. Okay, got it. Thank you. Take two. I'm going to be talking about a language called RESTful API Description Language. We've been using this at EMC Corporation with the REST Governance Board. That's a group that I chair. And our job is to teach people how to do REST, to do reviews of people's proposed REST interfaces, to make sure that we're doing REST in the same way. And we have been going nuts with some of the tools that already exist and the lack of the tools that we want. So we decided to develop something that met some of our needs. This has changed quite a bit from something that was presented at Malasage. We decided that the way we were doing it back then had some flaws. REST has a basic problem that Roy Fielding described this wonderful architecture that everybody adopted, at least in their minds, but he didn't tell us how to design REST APIs. We also didn't get a lot of tools that really followed his architecture in terms of API development. So you can understand the REST architecture very well and still not know how to do a REST API. This has been really frustrating for our developers because what happens is they go out there, they Google how do you do REST API design, they find different answers, they read different books. One of our experts recommends one REST book, one recommends another REST book. They both seem to be purist REST. They disagree on exactly what you want to do. Then they go looking for tools, and the tools don't support the kind of development that we've told them they're supposed to do. So basically we tell them, go do pure REST APIs, and they say, well, what do you mean? What are we supposed to do? They're a little bit baffled. They also need to create documentation and runtime metadata. They also need ways to make sure that their implementation matches their specification, the kind of thing that Waddle does, but Waddle isn't really RESTful. Roy Fielding got really frustrated with the number of APIs calling themselves RESTful. He wrote a variety of blog posts. Here's one of them. He says that RESTful APIs must be hypertext driven. We're at an XML conference. We understand hypertext. We think that we're experts on this. We're the kind of people who understand what it means to have structured documents with links in them, right? Roy Fielding says, I'm getting frustrated by the number of people calling any HTTP-based interface a REST API. If the engine of application state, and hence the API is not being driven by hypertext, then it cannot be RESTful, and it cannot be a REST API, period. But most REST APIs are something that is now frequently called pragmatic REST. I use quotes because, first off, the guy who invented REST asked people to please not call this REST. And I think it's very confusing. But Corey House wrote a great blog post called How RESTful is Your API? He's actually a fan of pragmatic REST, but he's also very clear about what the differences are and what the advantages are each way. He says, if you see a REST that claims to be RESTful, what it's really doing is saying, here's a bunch of URIs. I'm going to tell you which methods to apply to each of these URIs and what the conventions are for applying methods to those URIs. Okay? That's not necessarily bad. Those kinds of APIs work. There's good tooling for those kinds of APIs. They're not REST APIs. And they're not what we're trying to do at EMC. RESTful APIs must be hypertext driven. Okay, what that means is servers send the state of a client to the client in the form of hypertext. The links in that hypertext tell the client what they can do. And the way that a client knows how to use those links is they know what kind of document they're looking at, what media type that document belongs to, and what the conventions are for that link in that particular media type. In other words, what the media type description should tell you is what you can do with the links in the document, how you can move from one state to another. And that's not what most of them do. I'll show you a little bit of that in a little while. To give you an idea what a hypertext-driven API looks like, well, as human beings, we do this all the time, not as computers, but we look at web pages and we say, okay, let me read this thing, let me find a link, and based on what I understand of this particular media type, I know how to use those links, right? Now, what does that look like in hypertext? Here's an XML representation of a documentum repository. And you see that in this repository, I can look at my users, my current user, my groups, my cabinets, my formats, my network locations. There's various things that are identified by link relations. You see the rel equals here. They can also be identified by a path or a name of a link element, but link relations are a preferred way of doing it. Your REST client is supposed to use the rels to identify the links. They're not supposed to know anything about the URI and the href except that they can use it. There's an exception to that that's called URI templates. If you know what that means, you now know that I know that it's an exception, but I'm not going to go into that right now. Now, you can also do the same thing, JSON. You see here that I'm identifying link relations with a rel property, and then there's an href that identifies the URI that's associated with that. So what a REST client does is it reads the document, it finds the links, based on its knowledge, provided either to the developer reading ahead of time, that's what happens most of the time, or via runtime metadata, it uses those links. And the advantage of this is that it means that you're loosely coupled. It means that your clients and your server implementations can develop independently. On the cloud, it means that you can direct your links to different servers in order to balance your load. There's a variety of things that you can do that really basically mean that everybody can develop their server stuff without worrying too much about breaking clients. It's also very simple to write clients this way. So how do we make our tools RESTful? Well, first off, let's recognize that most tools are for pragmatic REST, not for real REST. And that starts actually with your JAX-RS annotations. Here's a tutorial, like many other tutorials, that shows how to use JAX-RS annotations. And here, he actually goes as far as telling you the media type that's associated with a GET. So you can say what the media type is with these annotations. You cannot say, here's the document that you're going to get in this media type. Here's the links that you're going to get. We've considered whether you should even be able to say that some links are required, some are optional, things like that. We haven't quite gone that far yet. But basically, what it does not tell you is exactly what a client needs to know. How do I find the links? What can I do with the links? Starting with the annotations, that then filters up through the tools. So here's a storage service described in Waddle. This isn't about media types or links. This is about something called resources. Resources are identified by hard-coded URI paths. There's not a link relation in the document. This is not designed to do what a REST API should do. There's a reason for this. This is the stuff you need to know when you're writing an implementation. And it's good to know what to do when you're writing an implementation. We do need that information too, but that's not what a client should be looking at. Clients knowing too much about the implementation is where type coupling comes from. Here's a Swagger document. Again, you've got fixed URIs and the operations that can be applied to it and the conventions for those operations. So that's exactly what we don't want to do. What do we want to do? We want to provide a user view of a REST API. In addition to that, we want to be able to provide the information that an implementation needs in order to implement that same thing, and have the implementation and the client get information that's consistent. The user's view includes media types. Within the media types, we have documents. These documents have links that are identified by link relations. If I know what document I have and what media type I have, that identifies the interface. In other words, that identifies the interface, which is the conventions for using that link. Let me say that one more time. The interface, which is the conventions for using that link in that context. Those conventions can use things like URI parameters, headers. There may be authentication that's needed. Here's an example of what our generated documentation looks like. Here I have a maps service. It's composed of a set of media types. In this case, I'm simply extending the XHTML media type, and I'm using the ping. I'm adding semantics using microformats that are embedded within the HTML. So you can either extend existing media types or else create your own. If I look at any of these documents, you'll see that I have a link relation, the methods that can be applied to it, then I have the conventions for the request and the conventions for the response. Either the request or the response can identify documents. You may be putting or posting, or you may be getting a document. And obviously I can go to the different documents. I can click around here and see what's going on. One particular document is known as the home document. And that is, if I know the initial URI for the service, where does it bring me? Then I have my link relations, which are used in the interfaces. And I have my URI parameters that are used in the interfaces. What I don't have to know about is what the URIs are, what the resources are. Okay, those things are server implementation details that the client does not need to know. Now let's start looking at the things that the server and the client need to agree on. These are the interfaces. Interfaces can be local to a link, or they can be shared in a media type. The interface basically says that for this link relation, if I do a get, my request is going to have these conventions. So it might have a set of URI parameters. my response is going to have these conventions. It might use some headers. It might have a document type. In addition to interfaces, there's something that is not shared with the client at all, which is the resources. What a resource does is it associates a URI or a URI template with one or more interfaces. Now, if you think about this in terms of how you implement these things, the tools for Java, RS annotations, and things like that are all based on the URI. The server needs to know the URI. Everything on the server side works with that. So what this basically does is it makes it easy to implement what we've specified and told the client about. Okay, I'm going to look at two sample rattle documents if I have time. And actually, given my proclivities, I might be better off doing this in Emacs. This is the document that we were just looking at, the maps document. The documentation element allows me to import an XML vocabulary. It can be an HTML vocabulary. We've implemented this for DocBook and for HTML for our own use. I can have documentation elements at various levels. One of the great things about using XML for this is that you want to be able to use things like tables and images and other kinds of things that are used to describe things in a documenty kind of way. You wouldn't want to write this stuff in JSON. Then I have an optional start element. The start element tells you what your initial document is going to be. I have link relations in the documentation for them. Then I have my media types. My media types have the documents that can be served. And my links here are going to identify interfaces. My interfaces have things like URI parameters and headers and things like that. And they say, if I apply this method to this link, what are the conventions? Okay. I'm not going to go into great detail here because of time, but I think you get the idea. And here are the resources that associate these things with the URIs. I think I'm not going to go into this other one because I want to leave some time for questions. What we've done so far is we've taken a precursor to this and we've used it to teach REST design to people at EMC. We found it very useful in a couple ways. You can be talking with somebody and you can write down the design quickly and show them the design. You've got a notation for thinking about this, right? We're XML people, we understand this. Having a model helps you think more clearly. Having a notation helps you think within that model. And designing the notation makes sure that you've got a clear way of thinking within that model. This gives us the tool for generating the HTML documentation. We found this very successful. I've talked to a couple of groups that were stuck, didn't know how to get their design done, and within a fairly short period of time, we're able to help them get started knowing how to design REST APIs. We've generated HTML documentation really just on a test basis for some of our APIs using this, and we're pretty happy with the way that it looks out. We haven't yet put this into production. We're at very early phases with this version of Rattle. We've made some significant changes in order to make it more RESTful. And there's a bunch of things that we need to do next. The first thing is we need to move from having a model to having a methodology. And by that, I'm using methodology with a small m, but what I mean is that the model is enough for me to think clearly and work with other people to where they know how to do this. A methodology is something where I can write down how other people should do it, and they don't need me there in order to do it. We need to have Java tooling using REST annotations. Java is probably the language for which this matters the most in our implementations. The nice thing about Java RS is because you generate the documentation from your implementation, you know that it corresponds to the implementation. A lot of that we can do with existing annotations. We may need to extend the annotations in order to do that. But we want to make sure that we can guarantee that the specification and the implementation correspond. And we're also working on how you serve up runtime metadata in JSON, XML, and in HTML. HTML for human beings, JSON for, it's easier to program with, XML for geeks like us. And part of that is making the metadata more granular as it's served up. Okay, I'm done. Any questions about this?
So there will be a question from Mohammed, right? Or maybe Michael has microphone, so we can start with Michael, please.
Is it possible to explain in a sentence or two what hypertext-driven means as Roy Fielding uses it, or does that involve attending a re-education camp?
That depends whether you want to get it by reading Roy Fielding or whether you ask me, I think. I feel like we spent a lot of time reverse engineering things that he'd written down. I think what he means by hypertext driven is exactly what I said about the server provides the choices in the form of links. And there's one quote that is probably best to start with here. I'll pull this up on the screen and then try to deconstruct it. It's this paragraph here. A REST API should be entered with no prior knowledge. Now let me put this in plain English. All a REST client knows is the initial URI and the media type. Knowing the media type means that the client knows how to find links and what they can do with the links once they find them.
That's where I drop down. I can understand a human understanding the difference between to book this itinerary, click here, to cancel and ask for a new itinerary, click here, but I have a hard time understanding how software is going to do that without before artificial intelligence people have finished delivering how.
You're making an assumption that I'm not claiming. So I'm not necessarily believing that software is going to automatically find this stuff out. We nevertheless do want to provide the metadata so that if there were software that's that smart, we can provide that structured information in the form of runtime metadata. So rattle is a vocabulary. If you understand that rattle vocabulary, then you can understand what this information means. And if you write software that's smart enough to use that, it can at least discover it.
Okay, so interacting with this requires no prior knowledge except the initial URI, the set of standardized media types, and some natural language in which the rest of the information is expressed.
Yes, I believe that the vast majority of people actually, programmers usually write the software understanding what the media type is. That's the way the world works now. We also very much want to serve up the metadata where what you need to understand is the language that describes the metadata, and then software that's smart enough to leverage that automatically can do so. That's one of the next steps that now, how far software is going to actually go with that, I don't know. We've had grand visions about that that haven't really been realized in the past.
Thank you.
So, Mohammed?
Yeah, reading the title of your presentation and knowing your background, I'm a bit surprised that you didn't relate it to XQuery in some sense and to XQuery to REST-XQ API. So, is it in completely different world, or has it something to be related in some sense, and if this, how?
I'm sorry, I could not hear what you said very
sorry,
clearly.
okay,
I'm sorry.
start again. I say, reading the title of your presentation and knowing your background with XQuery, I was surprised that there are no mention of XQuery at all in your presentation, first. Second, how does it relate to an XQuery attempt to do this kind of thing, which is called REST-XQ? How does it relate?
Okay. So first off, this has no direct relationship to XQuery. It's orthogonal to XQuery. The way that you implement a service is completely hidden to the client and should be in a REST API. Now, if you use something like Adam Rutter's annotations for XQuery, remember how I said that I thought that in the Java world we ought to be able to work with Java annotations to, and by that I mean to make sure that something corresponds to the specification, or also to generate this information from the implementation. I think that would be easy to do with Adam's RESTful annotations that allow you to implement RESTful services using an XQuery. And yeah, that would be a great tool to have.
Okay, so it's direct relation. We can do this. You said on Java, and we need to do Java, but we could do the same server-wise with REST-XQ.
Yes, absolutely.
Okay.
Okay. Any other questions, comments? I think. Okay, then. Thank you. Thank you, Jonathan. It's time for refreshment and coffee. After the coffee break, we will continue. The next presentation will be given by George Bina. Thanks. Enjoy the coffee break. We are a few minutes late, but this is not a big issue. So we can wait a few more seconds for the rest of people. The next presentation will be delivered by George Bina and Oxygen XML team. And we will see a truly multi-screen presentation if everything works or if most of things work. So the setup for this session was very complex, and it took some time. So good luck, George, and please go ahead.
Hello, my name is George Bina. Do you hear me? No?
Maybe it's muted.
Okay, now? Hello, my name is George Bina. I'm from Syncrosoft, the company that develops Oxygen. As I said earlier, we have here, we are 6 people from Syncrosoft here. 3 of them are working on the authoring part and 2 on the development part of Oxygen. Today, I will talk about XML authoring on mobile devices. And I hope to also be able to show you something, right? That's why we made all this setup. So first, a few words about mobile devices. They are continuously increasing. Probably every one of you has already maybe more than one mobile device that you are using, right? Like your smartphone, maybe a tablet. And in some cases, such a device may be the only way you can access information. We had an email recently on our support from someone asking if they can use Oxygen on an iPad, for instance, because they had someone with disabilities and he was able to use only an iPad. Initially, when I got my first tablet, I used that only for games. But in time, people start to use tablets also to do some work, not only for playing. So I think that it has to be a trend from play to work also on these devices. And also, the other days on my Twitter stream, one of the tweets pointed to an article on New York Times called Wikipedia versus the small screen. And there are some codes there. And I found interesting that also Wikipedia already considered providing an editing interface for mobile devices. There was another tweet, I think, that mentioned that in 2013 there were 1 billion devices sold, smartphones. So it's not, a market that you can ignore. And I didn't want to have Oxygen the second that will provide a solution in this space. So we started to look also what we can do in this space. For XML publishing, the output that you get from XML, a few years ago there were not so many mobile-friendly output formats. From Dita or Dagbook and so on. But now you can obtain different book formats like EPUB or Kindle format from Dita, so you can have that on your mobile device. And there are also on this website mobiledita.com there are a number of different web help outputs that are specially formatted to work on mobile devices. Now, there is some concern that you will not be able to edit XML on a phone, right? But there are, when you work with XML, there are more than raw editing. And one workflow that we've seen is the kind of traditional review process that works also with digital documents when they have XML and they convert that to PDF. And this is done in big companies, and they lose a lot of time with this. So they convert XML to PDF. There may be multiple XML files that result in one PDF. They send that out to reviewers, to people that will look and annotate on that PDF document, and in general, they can only add comments about what's wrong on that document. The annotated PDF comes back, and they align that, putting it side by side with a number of XML documents. And then they try to update, based on those comments, the information that they have in the XML documents. So there are a lot of manual steps, a lot of steps where you can introduce errors and so on. And this can be replaced with a direct XML review process where you have the XML files and you can annotate directly those XML files with comments, but not only with comments, but you can also propose changes to the documents using track changes markup, for instance. And then when the document comes back with the feedback from the reviewers, then all you have to do is to accept, reject changes, or if there is a comment, it's presented exactly on that part of the document. You don't need to align that with the document. I discussed with one company that used the PDF kind of review process, and they said it's a nightmare to identify which file, which XML file some part of the PDF refers to. Another use case that I've seen is that some companies need to get initial data. They have an XML-based process, but then they get initial data in Word, for instance, and then they run a conversion process. And then probably that, in some cases, is not 100% correct, and then you need to have a manual fix-up. So that's another point where you can bring in an XML interface to collect initial data from people directly in XML and bring that in an XML system. And probably you've seen during the demo jam, Alex presented some interfaces to XML documents that allow this kind of usage. So these problems can be already solved on the desktop right now. Not only Oxygen, but all the other XML editors provide change tracking, annotations, so that you can, bring that to users in some way and get their feedback. So what we wanted to investigate is how we can have this available also on mobile devices, and also the full XML editing support, maybe, if possible. XML authoring, let's say, because we target right now only this visual part, not necessarily the raw source editing. So let me try some magic number. We had some issues with the network here. We have a local network, but let's hope everything works and you will be able to see something interesting. So let me see. So we have this camera that films, shows the two devices, the iPad and the Oxygen. And the magic part means that we need to get this document, that this is a dogbook document, because we have also norm here, so I choose dogbook, not other type of document. So this is kind of a dogbook document that is rendered in Oxygen, and you have the track changes, comments, and so on. So let's try to get this on the iPad. And now is the magic part where we should be able to move. Let's see if we get it working on the iPad. Not all devices are, we also have an Android. I also have an Android phone. So this phone here, I hope you see it. And now we have the document on the phone. Right. So you can also see it here. It's the same document with the, the difficult part, for instance, is the row spans for tables that are, the table layout is also here, right? So let's put it back on the iPad. Okay. We have it back on the iPad. So now let's hope that the server connection works, because this is not a standalone application. It's a server-based application. And here you have, oh, sorry, let me switch to the iPad. Okay, so you can see now the iPad. So this is the dogbook document that we had, and we can see different highlights here. If I press on such a highlight, I don't know if you can see the comment down here, and I have this, can I have a pointer, maybe? No? So there are some arrows down there where that you can use to move between the comments, and here is a remove button in case you want to remove some comment. So let's say we remove this comment, and it's gone. If I have a change, like this, then the actions here says accept, reject, right? So I can accept or reject the change. But if I want to add a new comment, I can select something here, and I say add comment, and then I can add a comment about, this should be changed, for instance, should be rephrased or whatever. Okay? Okay, so now my comment is highlighted here, and the comment appears here when you look at it. But I was not very happy with this interface, so I said, what about if we swipe right? Why should not be able to see the comments here? And then you can browse through the comments and changes. And we made the video demonstration out of this, and it was like select here and accept or reject at the bottom. But what about if you swipe on such a change? Then you get the accept or reject actions directly on the interface. So let's accept this change, accept the other change. Okay. So basically this allows people to review DocBook documents directly on the iPad. Now let's switch to the edit mode. So when I'm in the edit mode, I get the keyboard, and I can add content here, right? I can remove content from the document. And let's see what else we can do. So if you swipe, you get this content completion and rename element actions here. For instance, if I say rename element, then I can select a program listing. So I can type to filter the available options, and then we can say a program listing here. And you know, the paragraph here is changed, and you can see also this in the formatting is changed to a program listing. Let's undo this change. And if I want to enter free markup, then I can type here. Yeah, and sometimes I will get also to this. So you can select an element and you have the acronym element entered, and then you can type something there. I can also turn track changes on. Okay. And let's say we save the document now. And maybe we should move back to my laptop. And the document is here. The modified content is here, right, in Oxygen. So how does this all work? We have to choose between different technologies that are available to build applications on mobile devices. One of the choice was, shall we make a native application or a web application? And of course, Oxygen being Java-based, we already had the experience that it's great to have an application that you can use on different devices, different operating systems, and so on. Plus, a native application limits you to distribute that only through an app store, while a web application is available directly to users. Also, having a web application allows you to send a URL to someone, and they just click a link, and they have that document already in front of them, ready to be edited, reviewed, or whatever. So we decided to go for a web application instead of a native application. And we developed this with the mobile devices in mind first, and then we test to make sure that it works also on desktop or other things. Any other device. We wanted to reuse existing technology that we already had for XML authoring, because otherwise I think it will be a huge effort to build everything in again, you know. And another thing that we considered was that a client-side versus server-side processing, how much you put on the client, how much you put on the server side. Because if I will use such an application to work with XML, I don't want to wonder all the time, will my battery drain up? Shall I stop? You know, I want people not to worry about this. So what we've done was to put Oxygen on the server side and just push the visual rendering of the document to the client. So most of the processing is done basically now on the server side. And the client just renders the XML document. For this, we tried a number of approaches, trying to render the XML directly inside the HTML page so we can reuse the CSS directly to style the content, the same CSS styles that we have. That does not work well because, as you probably know, HTML does not really allow you to put arbitrary tags inside, right? And it will mess with your XML markup, and you cannot really do that. Another option was to draw this view on a canvas. So just as we do in Java, basically, we render the document using a graphics object that draws paints everything on the screen. We tried this approach as well, but then we were considering current issues and events and all that on the canvas, and we were thinking that is not what we really want to do. And the third approach, and what we decided to use, was to convert the XML to an HTML5 document using data dash attributes to store XML-related information, and then convert also the CSS to match automatically to match this converted structure, so the document will be rendered in the browser in the same way as it is rendered in directly with the CSS applied directly on the XML document. So the current architecture looks like this. We have Oxygen on the server side. You can plug in all the configuration that you have for dogbook, for data, for any XML document. You may not have a special configuration, just an XML and a CSS that will also work. You will get that also in the web application. And you can also have plugins, and for instance, the plugins that connect Oxygen to a CMS. So if you connect Oxygen to a repository, you should be able to use the same mechanism to access and load, save files. So the advantages of this approach are that we reuse almost all the existing support that we already developed. Even custom actions that you define in Oxygen, in the Oxygen author mode, can be triggered on the web. The validation also runs on the server, where we have all the validation engines available, so we do not actually need to port them to JavaScript. The processing on the client side is quite minimal. So this approach is battery friendly. Having the model on the server, there's a potential for collaborative editing. So you can have two people share the same model and see, maybe what they are doing in the same time. As you have now in Google Docs, for instance, when you edit the same document. And as I mentioned, reusing plugins that connect to different repositories. The disadvantages of this approach is that HTML, JavaScript, browser is not at least is not my ideal development platform. As we go to all the corner cases, we get into all possible issues. And there's a lot of difference between each browser on each platform and so on. So it's a lot of work to work around the issues and try to find solutions to make it actually work. Oh. Okay, you've seen the demo. I just want to show you just one more document. And we also leverage device-specific input methods like speech recognition and handwritten recognition. And I have a video that I will not play now, but I will post it later, where you can see, you can enter with content with speech recognition or writing on my Android phone. And this works not only on mobile devices, it works also on my TV. I have video also with that on laptop, desktop, and any device. Our plans for the future is to release it first. We hope to do that in May. And then use it for some XML-based application for a weblog maybe, for a wiki-like website that has dogbook or a simplified dogbook behind it, for instance. Integrated with Google Drive or Dropbox, so you can have new dogbook, new data in your Google Drive as actions. Explore different ways for the user interface, and maybe create hybrid applications. And before the questions, I want to show you this cool plugin that we have. Basically, this allows you to open any file in Oxygen, and you just scan that on your iPad, and it's moved to your iPad. So this plugin opens a Tomcat server, and is configured with whatever we have in Oxygen as frameworks, and it gives you a URL to the current file. So then you can scan it, and you can quickly test, any file. And as I said, I just want to show you one file. Which is a very simple interface for data. Let me try to scan this. So I hope the network is connected. It should run quite fast. Well, the idea is that you can also test this, if you say open, you get this in the browser, and you have here the custom actions that allow you to add another section or to remove a section and so on, right? But you can access them on, you need to have the network connection working between these two. Yeah, now I have it here. Okay, so basically we have this, this is for the data entry scenario, where you can just enter information and then you just can type to execute actions and so on. Okay, so
Thanks.
That's it.
Thank you.
Thank you.
So I think we have no time for questions, actually, so please, if you have questions for George or his team, please go upstairs during the next coffee break or talk to him during the lunch, because we need to go ahead with the next presentation, which will also heavily rely on advanced technology. And the next presenter is Autumn Guelar. I'm not sure if I pronounce your name right, of Design Science. And she's going to talk about MathML, and the progress report.
so it's a pleasure to be here with you all, although I'm not quite sure how I feel about following up George Bina's presentation. My name is Autumn Cuellar. I am from Design Science. I'm a product manager there, and at Design Science, we make math typesetting software. To give you an overview of this presentation, we're going to start with a brief history of the MathML standard. Then we'll go into MathML's adoption into other standards. We'll take a look at where MathML software support is today, and then that'll take us to our conclusion. But before I reach our conclusion, as I mentioned yesterday, I do have a special announcement to make at some point during the presentation. But we'll just dive right into it. MathML, as many of you probably already know, is the W3C standard for encoding mathematical information in XML. In 1995-96, when HTML3 was in discussion, there was a general lamentation about the lack of support in HTML for mathematics. HTML, as you know, is the language behind the World Wide Web, which was built by scientists for scientists, and there was no way to communicate mathematical expressions except for with the use of images, even though math is at the heart of science. So this was considered a shortcoming of HTML, but the HTML working group faced two problems. One is that browser rendering technology was not at the stage yet where it could support the complex layout requirements of mathematics. And two was that to adequately support the requirements of the entire field of mathematics is a gigantic problem. There's just way too many requirements for the HTML working group to take into consideration. In fact, it was beyond the scope of HTML. So the W3C realized this was a problem, and they chartered the first math working group. The math working group also faced an immediate challenge. Mathematics are a largely symbolic language. So one symbol, here we have A cross B, could have several different meanings. This A cross B could be a simple multiplication of two variables, A and B. It could be the cross product of two vectors, or it could be the Cartesian product of ordered pairs. So even though we humans might be able to see at a glance what this A cross B means, the math working group realized that they would have to be explicit for computer interpretation of any math markup language. On the flip side, within mathematics, you can also use many notations to express the same meaning. Here we have 3 different ways of specifying multiplication. So not only did the math working group have to be unambiguous about the mathematics that it was encoding, but it also had to give people who wanted to publish their mathematical expressions complete control of the layout of the expression. The math working group solved this problem by splitting MathML up into 3 parts. There's content MathML, which gives the explicit meaning of the mathematical expression. Presentation MathML gives the intended layout of the expression, and then interface MathML allows you to specify both, to combine them as you need them. So this set a solid foundation for the MathML specification. And within 2 years, the math working group published the MathML 1 specification in 1998. However, as with any first version of a language, it's never perfect. So the math working group reconvened and followed up MathML 1 with the second version 5 years later. And with MathML 2, they've corrected some of the flaws that people had noticed in the first version. One of them is that MathML 1 didn't have any way to express a line break without the use of tables. And as it turns out, a lot of people want to use line breaks in their equations. So MathML 2 adds this, and then MathML 2 also favors cascading style sheets, which had grown more popular between 1998 and 2003 as a way of expressing style for their equations. MathML 3 became a recommendation in 2010, so it's just over 3 years old now. And with MathML3, math has reached a new maturity. With this latest version of the specification, the math working group carefully considered the needs of various communities with a stake in communicating mathematics electronically. For the publishing community, they added new line wrapping and line breaking features, because though MathML2 had added the line break, it just didn't go far enough. So with MathML3, you can now specify maximum column widths and page widths so that an extremely long equation will automatically wrap to the next line. And then it also adds alignment features so that those second and third and fourth lines will align up to that first line. Here we're aligning by the equal sign. MathML3 also adds elementary math notation for the education community. This was all possible in MathML2, but you had to use tables to do it, which was an inelegant way of providing this notation, and it could be very tricky getting it to look the same between rendering engines. And then MathML3 became a truly international standard by adding support for right-to-left languages and for notations that vary from region to region. Now, MathML was never intended to be a standalone language because mathematics are often used with some context. They're either parts of documents or parts of models. So to look at the success or failure of MathML, you really have to look at its adoption within other standards. For content MathML is ideally suited for scientific communities, and it has been adopted there for SELML and SBML. SBML is Systems Biology Markup Language. These are both biological modeling markup languages, and they both use content MathML. PhysML, as you might guess, is for physics, and PhysML also uses content MathML if MathML is involved. On the other hand, presentation MathML is used mostly within communities where you have to publish your mathematical expressions. DocBook, I think we all know what DocBook is. DITA is often used for help publication, help files, but can be used for other applications. The journal article tag set is used by scientific journal articles, or generally for that. The accessibility community has actually been pretty fervent in its adoption of presentation MathML. And the reason for this is that presentation MathML gives you the exact detail that is needed for, especially for assistive technology, to be able to get into that MathML to provide navigation and highlighting so that people with learning or vision disabilities will be able to comprehend the expression. That can be quite difficult if the mathematical expression is pretty complex. So this is why DAISY, which is used for digital talking books, NEMIS is a textbook standard, and PDF-UA is used for tagging PDF files for accessibility purposes. All of these standards also use presentation MathML, and they require it if you have math in your documents. But perhaps the biggest milestone for this STEM, technical, and scientific communities is the adoption of within HTML5 and EPUB3. The fact that HTML5 now supports MathML is a sign of just how far MathML has come. Math did not make the cut for HTML3, and as I mentioned, that's what prompted the development of MathML. It also did not make the cut for HTML4. At that time, math rendering technology had not advanced far enough, and browser vendors still felt that they could not adequately support the language. So now, with HTML5, we're finally getting to the point where STEM fields are adequately supported for digital communication and math. MathML's inclusion into HTML5 and EPUB3 is especially significant because what it means in theory is that content producers can expect their mathematical equations to have consistent display between all devices and all displays. HTML5 and EPUB3 have both been praised for their inclusion of different media types, and it allows us to take our digital content to the next level. And now this is true for the scientific community as well. with the inclusion of MathML. Now, we all know that computer languages are pretty much useless if you don't have the software to support them. So we'll take a quick look at where the software support is for MathML today. And the good news is that if you have to create MathML, it's now easier than ever. It's so easy that you can handwrite your mathematical expressions and convert them to MathML. And that's possible with tools such as the Math Input Panel, which now ships with Microsoft Windows as of version 7. Mobo Math supports older versions of Microsoft and the Mac operating system. And then Vision Objects creates a tool called MyScript, which is a web application for handwriting to MathML conversion. If you have to work with computer algebra systems, you can use Maple and Mathematica to produce MathML, and this is good if you have to take your models and then publish them, either with a journal article or a presentation. And Maple and Mathematica also support input of MathML. For document creation, some word processors and most XML editors now also allow you to create MathML, either with a built-in equation editor or with a plugin. Microsoft Word has its own equation editor. It has a proprietary version of MathML called it's OMML, which I always call OML. And, but they expect this to be converted to MathML. They even provide an OML to MathML style sheet within Microsoft Office that you can use. XML editors, Oxygen, FrameMaker, XMetal, Flare, all of these can produce MathML. For those applications that can't already edit MathML, there are a couple of software development kits available that enable you to add your math support, your equation support with MathML. My company, Design Science, makes MathFlow components, so I will unabashedly tell you that this is the best product out there for you. But we also, for certain situations, you can also use the Wirus suite as well. For rendering engines, MathJax is an open source JavaScript library. It's very popular for rendering your MathML on all modern browsers. That's, as I said, one of the most popular ones. MathFlow and JEuclid are other options if you have to convert your MathML to image files for inclusion within PDFs or other document formats. We've come a long way within the past 10 years with MathML support, but I've identified a couple of areas where some work is needed still. The first area is conversion from legacy formats. Proprietary math formats are especially difficult to get into MathML. If you have FrameMaker math in your documents or ArborText math, for example, you will either have to invest your own resources to develop the workflow to do that conversion, or you will need to hire conversion services companies such as Stilo or Data Conversion Laboratory. For LaTeX and Tech, you have several more options. Is LaTeX, somebody from LaTeX here? Does your software do MathML conversion? Yeah, okay. So you have LaTeX as an option. There are a number of open source packages that also do LaTeX and Tech to MathML conversion, but the problem with those is that they're generally not, they've either stalled as projects or they can be very difficult to get up and running. And so for that, it can be difficult. And then LaTeX also has a problem of a long tail of macros that often are not supported. For PDF documents, you're typically going to use some sort of OCR software to get your equations into MathML, to get your full document into an editable format like XML. But the only OCR software that advertises math support is the Infinity Reader. And that is not a 100% conversion, not a 100% success rate. So what happens is that you go through and convert all of your documents, and then you have to have somebody sit there and do a comparison of the source and the output to make sure that everything converted properly. The second area needing some work is with browsers and e-readers. HTML5 and EPUB 3 support of MathML is fairly recent, so the browsers and e-readers have not caught up yet. We do have the interim solution, which is MathJax. I already mentioned that. However, it is not the best long-term solution. And this brings me to the announcement I was going to make. I have a special guest here with us. Well, I will be bringing in a special guest. Frederick Wang started a crowdfunding project recently to improve both WebKit and Gecko's support of MathML. And I'm happy to announce that Design Science, in conjunction with XML Prague, have made a contribution to his crowdfunding project. So he is going to join us to talk about what he's going to be doing. So let me just try to get him up here. Hopefully this will not have any problems. And while we are connecting, I just want to give you a brief introduction of, hi, can you hear me? Oh, hang on just a second. I just realized that I never turned my speaker on. Hi, are you able to hear me now?
Yeah, I can hear you.
Okay. Would you all mind giving a round of applause so that Fred knows that you're here?
Thank you.
So just to give a brief introduction of Frederick Wang, he is an independent developer who has dedicated a lot of time in improving math support on the web, especially. He's worked on the Mozilla and WebKit MathML projects. He's contributed to the MathJax project and also to MediaWiki Math. So, Frederick, would you mind telling us a little bit about the status of math on the web?
Yeah, sure. So, as you probably know, only Gecko and WebKit browsers have some MathML support at the moment. But the problem is that the work has mainly been driven by volunteers so far, so it's hard to get some good quality. However, there have been two improvements recently. So one is that Wikipedia is finally going to switch to MathML support. So at the beginning, they will just use native MathML for Gecko browsers. And for the other browsers, until they get better MathML support, they will serve SVG, which is converted server-side from MathML. And another improvement is that many websites are now replacing images with so MathJax, and so they are now using MathML internally, even if they don't serve the output yet to the browsers or to accessibility tools.
Okay, so you've just mentioned MathJax. Since MathJax is used for rendering math on the web, how is that not sufficient as far as MathML, browser support of MathML?
So perhaps the most obvious issue with MathJax is that it is big and slow. And so, for example, MediaWiki developers were not willing to switch to the client-side MathJax output. And other issues with MathJax is that it requires JavaScript. So, for example, you cannot use it in a standard SVG document or in web feeds or in search results. And there are also many incompatibilities with CSS. So, in general, web developers are used to style sheets, but with MathJax, sometimes the CSS rules won't apply, or sometimes they will apply and conflict with MathJax's own rules. And there are issues with fonts too. So, for example, from JavaScript you cannot access some non-Unicode glyph, or you cannot have access to font metrics and all the font data, so it's not possible to get arbitrary support. Another thing that is different in MathJax is with web fonts. So in general, with web fonts, you get rendering of the page, and when the web fonts arrives, the page is redisplayed. But with Majax, you'll have to wait that they arrive before you get the rendering. And finally, there is an issue with dynamic update of the page. So if you modify the MathML DOM with JavaScript, the page won't be updated. Or if you zoom in or if you rotate your tablet, the page won't be reflowed.
Okay, great. Now, can you tell us a little bit about your mathematics and ebooks project?
Sure. So it's a crowdfunding project. So the idea was to gather individuals and organizations with interest in MathML in order to fund development. So by the way, I'd like to thank everybody who contributed to this project. So I know there are some people in this room. So thank you, and I also like to thank Design Science and XML Prague for their contribution and for letting me speak today about this project. So thank you again. So, about the technical aspect of the project, there are three aspects. So one is to improve WebKit support. So WebKit support at the moment is only basic, so the focus will be on fixing the main bugs, so in particular the stretch operators. And in Gecko, the idea will be to implement the so-called math table, which has been introduced by Microsoft in order to get high quality. And finally, the last aspect is to write some example of scientific documents, so in particular in ebooks format. So this document will show interactivity with JavaScript, mixing MathML with CSS or SVG, or using Unicode, right-to-left interaction. And it will also mix with other HTML5 elements like Canvas, video, WebGL, etc.
Awesome. So I do know that others in this room have contributed to the Math and eBooks project. Can I get a show of hands if you have already? Thank you so much for your contribution to his project. We are looking forward to Frederick seeing what he comes up with. Now, if somebody were still interested in, or an organization were still interested in contributing, how would they go about doing so?
Okay, so I'm self-employed, so if people want, if some company want to contribute, they can just contact me and we can find an arrangement. And another thing that I'd like to mention is that other people are interested in MathML. So in particular, there is one Spanish consulting company which is working on WebKit development, and one of his engineer is really willing to work on MathML, so you can also contact this company. And I think Otan has some contact information at the end of our slides.
Great, thank you, Frederick. I will open it up to questions in just a second, but I did want to go ahead and show that page that you were mentioning. We do have information here on how to both keep up with Frederick's project, and also he had mentioned the Agalia project. The contact information is down here as well. So we are very much looking forward to hearing more about the Math and eBooks project. Hopefully it will improve the MathML support that we're already seeing on the web. That's just one area of improvement that we could still see within the MathML community, and we're looking forward to that. But now I will open it up to questions. We'll keep Fred on the line in case you have questions of him as well, Frederick. Thank you.
Thank you, Autumn. Thank you, Frederick. We have time for one or two questions.
Yeah, is the thing on? Okay, you're working on WebKit and Gecko. Google Chrome isn't using WebKit anymore. do you expect Chrome to fully drop MathML support in the near future? For mobile performance, for example?
Did you hear the question? I don't know if you want to take this one. He had asked if this is Robert, by the way, Robert Boersma. He had asked if we expect Chrome to drop MathML support completely now that they've moved away from WebKit a little bit.
So, yeah, at the moment, I think Chrome developers are not willing to add the MathML support, but in theory, they are using Blink is based on WebKit, so we expect that if we reach good MathML support in WebKit, they will maybe change their mind and enable MathML support again in Chrome.
Now, the good news is that the scientific community is getting pretty riled up about the lack of support in MathML in Chrome, and so hopefully, you know, we've been pretty vocal about it. And if you have any interest in MathML on the web, please let the Chrome developers know how important it is to you to see them improve their support of MathML, or to add support at all, really. Any other questions?
Yeah. Any last question?
Okay. Excellent. Well, thank you very much for joining us, Frederick. And
Yes, thank you.
I'll let you go now.
Thanks. So let's continue with the last before lunch presentation. John Lumley is going to explain us how to finalize a standard.
Okay, does that sound okay? Sounds all right from here. Everybody can hear me. Okay. I'm going to talk about finalizing a small standard. The synopsis is it's about refining an XSLT extension library to 1.0 status. And I'm going to talk about the reflections on that experience. This is not rocket science. You can switch your brains off for a bit. It's more about what happened, the types of major issue that appeared, and some lessons and some unsage advice. One footnote is, I'm talking here, I use XSLT. It's actually for XPath, XQuery, but my world is XSLT, and that's what I'll, when I say XSLT, read the others in. Right, standards, the more the merrier. We've heard a lot over the last day or so. We started back in '98 with XML starting and HTML4, and then there was the XSL experiment, and from that came XSLT1. And as Mike told us earlier, these have long gestation periods, 3 years to, and then another 3 years of sort of bedding down, so they come at about 6-7 year intervals down the pike. And then we're going up towards XSLT3. Now, unfortunately, for many or some application developers, they need that little bit extra. And it was very perspicacious early on that people said, right, in XSLT1, we will want to be able to, people to put their own extensions in, and people did. But then the question came about, could you get some commonality in terms of these libraries? And we got some notions of community spirit, and particularly the EXSLT community back in basically 2003 to 6 period, worked on some of these in a semi-formal sort of way and produced particularly the math library, which then got back into XSLT2. Actually, I think it's XSLT3 it became finalized in. And that sort of petered out, but another one started up that Florent Georges started, what, 3 years ago, the EXPath community, which basically has worked on producing a number of standards with a rigor, admittedly on a very small scale, which approaches that W3C is trying to do, not necessarily bureaucratically, but the specifications look in similar way. They've got similar sort of standards about test suites and that sort of thing. And they did web app 1. Now, this year, this conference last year, I wasn't here, apparently something came up about binary manipulation, and it was suggested that it might be an EXPath standard, and Jerka basically set off apparently like out of a trap and got a version drafts put together in about a month. Now, that has now got to a 1.0 status as of December, and the question was, what happened? I got involved in doing that at the behest of Mike Kay. It's not rocket science. It's 26 pure functions and 38 signatures with one main type of the base 64 binary. It doesn't do any I/O. It picks that up in bulk from the EXPath file module. It has things like generating binary constants, basic operations, bitwise manipulation, probably the most important thing, stuff for encoding and decoding strings and numbers. And the Saxon implementation is basically a single Java class with about 1,000 very sparse lines with 56 methods in it. And there are two sets of test suites developed independently that are a couple of hundred each. And that's sort of about it. It's more about how did this come about? Well, am I certified to do this? Qualified might be a better term, but certified is much nicer. I spent 25 years working at HP Labs in Bristol. That's me much, much younger. And for the last 5 to 7 years, I've been working on document engineering. And then I actually did a PhD in this one on the work that I've been doing there. And all the work I've been doing has been on an XSLT SVG architecture, using Saxon very extensively and building extension functions for doing all sorts of interesting issues. And at least one person in this room knows exactly what I'm talking about. So I then started doing some part-time work for Saxonica last July. And the time frames were roughly this. I started on the 1st of July to study the 12th of March spec, look at all the previous comments, which had happened basically in April, May, to instigate some more XPath discussion, and anybody who's been involved in these knows that they come in leaps and bounds, and built an Saxon extension class and test suite and got it running, and issued a revised draft at the end of July. It was actually 10 days work, including the familiarization with the build environment for Saxonica. We then went through 2 more revisions, one in the middle of September and one in the middle of November, working our way through the different issues, which are far, far smaller than, for example, the working groups have to deal with, but they still give some interesting issues. And a final version was published on the 3rd of December. There are about 100 postings with 6 major respondents during this operation. We had sort of 3 or 4 major issues that came up, major by the size of this particular library. And it was, unsurprisingly, bursts of frantic activity interspersed with long, quiet lulls, and then thinking, well, we should push something back and getting it going. Right. The big thing is you producing this specification, which looks like an XSL W3C spec, but is quite a bit smaller. You have to prove the specification. You have to basically work on, is it right, is it consistent, and everything else that you need to deal with that. Now you could, if you had real leisure, you could try and do this sort of proof with mathematical, theoretical background. You do a lot of discussion. You hopefully don't have too much argument. But one of the most important things that I certainly found is you must implement it. Especially as the editor of such a thing, if you're not implementing it, you're not actually experiencing what it actually means. And one of the things that also became important to me was the notion of what I call the medium-sized example. Something that's big, not completely trivial, but big enough to put inside the specification itself and to illustrate some things, and I'll show you what I mean. The specification itself should be littered with small 1 or 2 liner examples. This is one that came up later which showed that it answered the query, in fact, that big long shifts of longer than 1 byte were seriously possible. But understanding the purpose of the specification and pieces and how they interact requires these medium-sized examples, and this is one that you'll find in the spec, which is the standard thing of how big is my JPEG? And it basically involves 2 things. One is to search the binary to find the appropriate tag field, and then to decode 2 other numbers that are at a fixed offset from the beginning of that field. Now, one of the other things we did in this was use another example, which was ASN1 integers that Mike suggested, which took me back a very, very long time, to some time I was working in networking 20 years ago. And this was a lovely little one, because it's quite interesting. ASN1 is basically encoding of variable length numbers, very large numbers possibly. And it has a tag for an integer, it has a length field, and it has a series of octets. The problem is that the length field, if there are less than 128 octets, that length field is 1 octet long. But if it's longer than that, the length field itself is variable. And in fact, it can be up to 128 octets of information about how long the rest of the thing is. So it's more than the age of the universe squared. So you get 100 looks like this. 2 is the tag. One byte saying there's 1 octet which has got 100 in it. 300 basically looks like that. 256 plus 44. And 0 has no data at all. So what you do is basically use this as an example in your particular piece, and these are some pieces. It's a helper function, and this is the function that encodes, and there are some examples here. And one of the interesting pieces was I suddenly realized that I'd been working with sort of numbers up to sort of longs, and then I went into big ints, and it just carried on working. And then I said, all right, well, I'll just cut and paste a 900-digit number. And Saxonica just takes them in, pushed it through, out came an answer. I wasn't going to check it all, of course, but I could then put that back through the next piece, which was the decoder, which was a little more complex, actually, used a lot more of the features from the library. And lo and behold, the output that came back was the original 900-digit number. So that had the advantage when these medium-sized examples, you may get serendipity of having testing some of the scaling issues, for example. Okay. Well, other lessons that came from them are you've got to think about the policies when you're putting these in. Policies are choices that will need to be made in several places, either in the standard itself or in a context that's wider. And for example, we came up late in the issue in this development of some cases which actually were policies for XPath itself. Okay. I'm going to go through some of these ones, 4 of these quick examples. The first one is naming of things. I mean, you've got this library of functions. They could be called F1, F2, F3, F4, or F5. That'd be fine. They're entirely separate and distinct in namespace, but they're not exactly terribly useful. Names have use for when people are writing things. And this is an example where the binary subsequence. This was in the original draft that Jerker put together. And one of the things about there was it became clear that things like the names of your arguments being consistent right throughout is very, very helpful indeed. So we've got here that they're all being used in the same way. But it's also useless if names become too big or redundant. In this particular case, the binary hyphen at the front, given the bin colon, was really redundant because it's all about binary. So we could drop that out. Now we've got bin subsequence. Oh, that's interesting. Hang on. There's function subsequence. All right, different namespace. But actually, the semantics aren't quite the same. The semantics of this is actually closer to substring than subsequence. It takes a binary item and produces a smaller binary item. Okay? So we could call it sub-binary, but then you have to be thinking about this. Sub-binary is a hell of an ugly word. So somebody suggested part, and that's what it became. And it worked quite nicely. It's short. It's like, you know, and we got join and equivalent like that. So you have to think about your names. Anything that's useful is going to have errors in its execution or be thrown the things that give errors. So this was the original set of error codes. We changed them because eventually we decided that actually meaningful names for errors were better. So that's what happened in 20th September. And then by the time we got to 3rd December, we'd actually trimmed that down. One was no longer relevant. It wasn't going to happen. One, we changed name because it was more general. And to 2 others, we basically said, actually, you don't need these two to be separate because you can actually choose between, detect which of these was the case by putting information on the error variable in a try-catch situation, at least for an XSL anyway. The big issue that came very late in the last sort of month was what I call arguments on the edge. And this came from insert before as an example, where insert before puts binary piece inside the middle. Okay? You could put it together by parts and joins, but it's easier to have one function that does it. And the questions then came, what happened if these arguments were empty? And there were 2 senses of that being empty, one being an empty string, I bound null, or sorry, an empty sequence, or actually an empty binary, which isn't the same thing, just as in string. And those were fine, we could handle those. The big ones were what happens when you went before and after the ends of the arrays. And we actually spent a lot of time getting, if we got that sort of very much nailed down early on, it would have made a great deal of help. And right at the end, we got this thing I called the future is somewhere else. We had this packed double, and somebody said, oh, well, can we change it to a packed double with a double star rather than just a single double? And by that time, we just had it. And we said, right, that's going to wait too late. It's going to go for version 1.1. Then somebody said, okay, what version am I? And then, of course, we realized, how do we identify the version? System property bin or bin version or a function. And this was very late in the day, and somebody said, oh, that's too late. We'll leave that for version 1.1. And of course, you'll now understand that there's a sort of a self-fulfilling prophecy down here at the bottom. So that's actually an XPath issue as much as it is just ours. Okay, right. The other thing you should do when putting all these standards together is that you consider you're a software worker. And you're working in declarative space, and you've got tools, so damn well use them. We're used to algorithms plus data structures in programs. An equivalent might be tools plus declarations equals specs and tests. Copy and paste is not necessarily your friend. Use it sparingly, or do not use it profligately. Think about what you want to do, and think about the consequences of what I might call imperative actions. It's much better if you can find something to put some declaration in place. And there are lots of places in these areas where there are declarations. For example, in the binary, we have the function catalog. Now, the file one before hadn't used this mechanism. And this contains a hell of a lot of stuff you can use. It contains signatures, which are used to generate the spec itself. They control summary. They contain rules, which could even be more declarative than we're seeing here, which is basically a series of HTML stages. We have sets of errors and references, and we have notes, so they can have examples and that sort of stuff. But this is a resource that you can use because pretty much all our documents, our tests, and even most of our programs are in XML. We've got the function catalog, we get Qt3 test suites, we've got the spec itself. We have a superb tool for basically manipulating this stuff. It's called XSLT. You can just pull these things together in various ways, and you did. You can expand the test sets to basically generate test sets for yourself. You can document the test results by pulling stuff through from the test results in the catalog. You can basically produce implementation documentation, which is one of the things I'm doing with Saxon for this one. And you generate the spec itself, and the man at the back there is basically, I keep seeing his name all the way back, this history of the spec style sheets and the cascading of them sitting on top of each other. Okay, the other thing you have to do is to be realistic, especially in these sort of small things. We haven't got all day. You're trying to sort of chase and give some sense of solidity for people for a year or two so they can start using it. Focus on the core, get the essential elements working first, and draft the rest in XSLT. I mean, there literally for this module, probably there are 2 or 3 essential functions. Actually, the numeric decodings probably are the ones that do need to be there very specifically. But the rest you could draft out in XSLT and then progressively move them into actual spec and into actual implementation. It doesn't have to be perfect. It has to be reasonably robust. But it doesn't have to handle everything. Not in these cases. It's enough to give enough to start this particular area off and push things, let people work on it, and let both application developers and implementation developers work against that standard. There is an issue of pragmatism versus purity, which doesn't appear in this particular piece, but it does appear in the file, for example. We've done lots and lots of hard work to make XSLT pure, but there are some uses that may require side effects. And the best example, a very simple example of this would be, this is a little piece of code which is writing PDF directly from SVG by constructing little fragments in binary and then putting it together. And it's choosing, in this particular case, to use the file append onto a binary. Okay? And the problem here is that the for return need not necessarily be done in the same sequence, provided the answers are actually pulled back together. So you could find if where you wanted this graph looking like that, because some of these pieces, which were the data points, have not actually been written in the order in which you thought they were being written. Okay. And if you really want to go down this route, I started having nasty pictures about monads and everything else, and they're saying, oh no, I don't want to go back there again, please, no. But this is an area that's going to start increasingly becoming apparent with some of these sort of extension systems. Okay. Right, acknowledgements. Jerker started this thing off. I've been helped greatly by him. Florent basically gave a lot of help, particularly in the early stages when I was new to this particular thing. The XPath community chipped in, and especially Christian Grun later on. He did the first other implementation, and Mike Kay kicked me into doing this, and I quite enjoyed it actually. Quo Vadis, well, there's another one on the stacks on archive format, which is basically the last main published draft is in September, and there's an editor's draft around at the moment. And we really want to try and get this one going in the next couple of months, take it close to the 1.0 standard. Similar thing, it's basically manipulating zip and archive files in particular areas. And it has an interesting issue about how we use maps or not use maps. And that's it. I'll take questions.
Does it work? Yeah.
Yeah.
I was wondering in how much you would like to pair the function signatures that you create in the binary module with the ones that are already there in XPath. You showed the subsequence as an example.
Yeah.
I happen to notice that in XPath you have XS double as
yeah.
Positions, and you use XS integer.
That was actually that was a question that I asked Mike at one stage early on, and his reply was that double comes from the days of XSLT1, where you didn't have error recovery systems, and you tried to build systems which are much more amenable, but that the general philosophy was going forward into 2 and 3 was that things that really should be integers now, and not attempt to go back to meet that, because this is never going to be running on under XSLT1. I mean, it's, you know, the archive one is questioned about whether it'll even run under 2, parts of it will run under 2. So that was a question where a policy or a philosophy from outside, which is saying going forward, saying you know, integers, if they really are integers, then they should be integers, was something that was like part of the policy effectively, but a pretty high level perhaps an unwritten policy. Okay.
So you look to the future instead of for backwards compatibility.
Yes,
yeah.
and you know, you're not going to run this inside a browser. You're going to be running this in server systems and generators and all that sort of stuff. So that was the philosophy we had.
Makes sense.
Thanks. Mohammed, next question.
Yeah. Very good presentation, by the way. Thank you.
So I've done quite a number of the years. Actually.
You hear me? Yeah. So, how do you think this could apply to other kind of specification? Because it seems like you did something that the W3C looking for ages, to do quick and agile specification production. What would be your advice?
The thing with this particular module, you could clearly see that what it needed to do was pretty simple in terms of the variety of operations that were going to happen, and you didn't need to do more. There's a question about whether some occasional convenience function was there, and so I could do that quite easily just by thought experiment as much as anything else. If you've got something much more complex, then you need to be somebody who's using that, the implementer or the editor needs to be somebody who's got a fairly keen interest in that particular application area to do it. So for example, if you're doing something on geolocation module, for example, then I would say that would have to be somebody who's got a really strong interest in basically in maps and geolocation and that sort of stuff, and a lot of background from that particular area. So I think it depends upon what people, the generality or the locality of the application area they want to try and deal with.
Another question, please.
Yeah, Dave Pawson asked from afar via Twitter, what do you mean with draft out in XSLT? Is it writing an XSL function as a stub?
Yes, it means basically using many of these things. Once you've got certain small pieces going in the extension function in the regime, you can write out effectively a piece of XSLT function that will do what you want to do. So, and then test that one out, and then you progressively you can spec it that way and test it that way, and then you don't, as an implementer, when you're doing a parallel one, you may or may not move it into Java or whatever you're going to do. You know, we live with that language. Just use it as much as we can. In fact, it's going to be even better because some of the stuff with packaging, we're going to start finding some of these features and functions appearing not as extension functions, but as loadable XSLT functions. And we've already got that in the proposal for XSLT3 on its JSON to XML support. The The JSON to XML is a function that has to be implemented either as an extension function or inside the system itself, whereas the XML to JSON is actually a style sheet. And it will be a style sheet package, effectively.
Okay. Thanks.
Okay.
Anyone else wants to ask anything? No, we are done. Thank you so much. Before we go for lunch, I would like to remind that that today's very last session is an interactive session. This will be a discussion chaired by Robin Bergeron about, this guy, about 25 years of the web. And because this should be a discussion, we will need your input, we will need your questions, your opinions for Robin, so you can think about it during the lunch and during the afternoon, and please be ready for this discussion. Yeah. And what's happening with taxi?
They can register taxi in the lobby there.
Taxi is waiting?
No, they can put them.
Yeah, and the very last reminder is that you can, if you need a taxi, please stop at the registration desk and just tell them when, what is your name, and how big is your luggage.
Anyone else for this beginning bit?
So, you heard that there will not be markup.
Yes, yes.
So, summer school, balisage, and XML.
I'll do. He's not here. I don't see you, Mr. Foster. Yeah, okay. All right, cool. Thank you very much. Welcome back. We're on our last leg of this XML marathon. Before we start up with the talks, we have a few messages from our sister conferences. The first one being Balisage.
Good afternoon. I am here to invite you all to Balisage, the markup conference. You notice that casual assertion in the. It's a very good markup conference. It's as good as this one in its own way. 5 to August 2014. This year, no longer in Montreal, but just outside of Washington, D.C. So be prepared. Don't book your flights for Montreal unless you're planning to go to Montreal for other reasons. This year, the pre-conference workshop symposium on Monday, the 4th of August, chaired by Robin Bergeon there. On HTML5 and XML mending fences. So if Robin's paper yesterday and the interactive session this afternoon persuade you as an XML person that maybe the time has come to start grappling more seriously with HTML5, this symposium is exactly what you're looking for. And if you are one of the web application people who is wondering why the XML people are not yet grappling with HTML5, this is your chance to help them do so. So come to that symposium, offer papers for that symposium. The paper deadline for both Balisage and the pre-conference symposium is April 18th, so you still have time to decide on a topic and write it up. And the third thing I need to announce is that this year, as in the past, we expect to have a student support program. So if you are a student interested enough in markup languages to attend XML Prague, then you are a student interested enough in markup languages to benefit from coming to Balisage. And if you don't apply for the Student Support Award, we cannot help support your travel. So apply. It is the deadline for applications for the Student Support Awards is the same as the deadline for papers, April 18th. It is not absolutely required that you submit a paper, but it's a great opportunity. Everyone who talks to me about it says they get better feedback from Balisage reviewers than from other people. And students who have attended in the past say it is a slightly friendlier audience than your typical CS conference. So, wonderful opportunity for a student. If you are a student, apply. If you have students and you are here, then you presumably have students who are interested enough in markup to benefit from Balisage. And if you're not telling them to apply, why not? And if you write me, email, I will send you the flyer that we are creating for the Student Support Awards for you to put up on the bulletin board in your department. And if you don't have students, but you know students, tell them too. Okay? Thank you very much.
Thank you. Thank you, Mike. Next, we have Philip Fennell talking about the XML Summer School.
Hello, everyone. This September, 14th to the 19th, will be the next instalment of the XML Summer School, held in Oxford in the UK. And it's an excellent venue for not only people coming to XML for the first time, there may be people in your organizations who need to get up to speed with what's... Sorry? Not close enough. Yes, the XML Summer School. Plenty of an opportunity for people new to the areas of XML to get up to speed with what's happening, plus you have access to some of the greats in this field to actually talk about what's happening in XML at the moment, where it's going. There's also the alternate track within the school on linked data, which will be covering many areas of RDF and the semantic web and its practical uses. And there's plenty of good social events in the evening as well, in and around Oxford. So I thoroughly recommend that you have a look at the programme for this year and make sure you sign up and come on board and see what's going on, because it's an excellent opportunity. Thank you very much.
Thank you, Philip. And just one more announcement. I can't see Charles Foster in here, but I also want to briefly mention XML London is going to be happening this year as well. I don't have any details, so you're going to have to go to the XML London website. Sorry about that. Right. We're going to start a kind of publishing track. First talk will be from Liam Quinn. Liam? He'll be talking about publishing in style with XML. And after that, we'll have Tony Graham, and then we're going to have a panel talking with Liam leading on publishing. And just before Liam starts, we also have a panel at the very end of today where Robin Bergeon, we get to throw rotten fruit at him about what we don't like and on the web and blame him basically for everything that's wrong. But if you could come up with any questions so we can stump him and make his life good and difficult at the same time, that would be great. Right. Over to you.
All right. Do I have to... Am I on? Yep. Can you hear me at the back? No. If they say no, they must be able to hear me. I can try it higher. Is that better? If I put it here, you are right. So it is working. Not sure I want to be filmed with a microphone in my beard. Has it already happened? It's already happened. But we'll try that. How's that? No. How about that? That's better. All right. We'll try it. If it doesn't work, then I'll go back to having it in my beard. Why not? Why not? This is Liam talking about publishing in style with XML. This is not Liam talking in style about publishing. Words are important things, aren't they? Okay. And a graveyard. So just to give a little bit of context, is anyone here using XSLFO? Awesome. Great. So XSLFO is not dead. Lots of people here are using it. Unfortunately, not many people want to work on it today. We closed the working group because no one was showing up. Is anyone here using CSS? No one, okay. Is anyone here programming Perl? Okay, wow, all right. People will admit to it, this is good. I don't know if you read XML Dev, but there was a thread recently talking about how bad all Perl programs are and how everything in Perl is crap, based on having glanced at a Perl script 10 years earlier. Well, that's what it felt like reading it. You know, 20 years ago, I looked at Perl and it was a mess, and therefore all Perl is a mess and it continues a mess. I've met people who looked at XSLT not 20 years ago perhaps, but 12 years ago, and one person had just inherited 1 million lines of XSLT to maintain. But formed an opinion and then said, I ran screaming. That same person actually became quite a fan of XSLT, so it's worth looking back, it's worth going back. But I'm sure there are people here who remember printing with a web browser like Mosaic or Netscape, and it printed, and when it got to the bottom of the page, if that was halfway down a line of text, well, it broke the characters in half and started on the next page with the bottom half of the characters. It really did. Today, things are different. Cool, that's good. So, I'll have to try not to do that, sorry. So we're making CSS better. I work full-time for the World Wide Web Consortium, and part of my role is
in the publishing activity to try and make CSS suitable for publishing books. So should you move to CSS is one of the questions that I'll be trying to give you some context to answer. There isn't an easy answer today. According to Publishers Weekly, printed book sales in a number of areas are increasing, continue to increase. It tends to be things like reference books and art books and photography books and children's books. Certain areas of children's books, not all areas. Sales of aircraft manuals have also increased, but Publishers Weekly doesn't track that. That's just because some big airplanes sold. And XSLFO is not dead. I come neither to praise it nor to bury it, because it's going to continue to be around as long as people use it, and there are still products and they work. We've got plenty of people in this room using XSLFO, and I've not come here to say stop. So why am I here? Why would you look at CSS? Well, let's look at some reasons. This is the logo of the Open Web Platform. Has anyone here used the web? A couple of people at the back. Okay, great. So websites, of course, use HTML or compatibly XHTML if you use the polyglot form, and CSS. Has anyone here used CSS? I don't think I've asked that question. So, yeah, anyone here allergic to shellfish? All right, because I'm going to be talking about crab salad sandwiches quite a bit. So EPUB 3, of course, uses HTML5. EPUB 2 used XHTML 1.1 with CSS. And if you're a publisher, you're quite likely to have to share CSS style sheets with your EPUB productions, with the web, maybe with internal sites. And if you can talk to a designer who is a web designer or an EPUB book designer, then there's someone who knows CSS, probably, or at least has some idea of what you can do with it, because otherwise you're wasting your money and you're talking to the wrong designer, right? So it turns out, once you've done the EPUB design and you're simultaneously working on the print design, lead times are different, but the designers have to work to both platforms. And you don't want to talk to two designers, partly because that's expensive, but partly because you should always talk to an odd number of people so you get majority opinion, right? You certainly don't want three designers in the same room. That would be as bad as having three software architects in the same room. So what's happening is the large publishers are employing designers who are familiar with CSS to design print books. Of course, they're familiar with print as well, but they're increasingly familiar with CSS. And what they're finding is when they move to CSS for print, that their time to market goes down. One of the big 6 publishers told me that they'd gone down from 6 weeks to 2 weeks to do the formatting for a typical New York Times bestseller style of book that's producing a print book from the XML files that they've got, or XHTML files in their case. They were taking 6 weeks with XSLFO, they're taking 2 weeks today with CSS. And that's largely, my take is that's largely about the people they've got and their environment and the tools they've got. But the tools they've got are based on the open web platform. They're based on the web. Or at least the interface to those tools is on the web. Okay, so I mentioned Perl, and 300 years ago when CSS implementations were pathetic, and the CSS working group decided not to do advanced features like page numbers, and running headers and footers and footnotes. They called them advanced features. That's not me being sarcastic. They actually used that phrase. And quite a few people remember CSS that way. But CSS has changed. It's not what your great-grandma used. It seems to be causing hysterics over there. Hopefully it's someone else And CSS now has more than 60 documents making up the specification. It's a bit of a nightmare. They all interact with each other in undocumented ways, in ways that are not obvious. The platform itself using CSS, the next layer up, has matured into a platform that's being used for fairly complex web applications today. It's almost as good as a graphical toolkit of 20 years ago. But it's distributed, which the toolkits weren't. It's pretty hard to find your way around, and the focus of development has been on web applications. Focus has not been on print and what they call paged media, which includes ebooks that don't scroll, but you swipe to get to the next page. Or if you're George Beaner, you swipe and your book goes onto someone else's phone. There's probably laws against that. So it's been pretty bad, but it's changing. Things are changing. And we saw that it was bad. We're not actually angels, but maybe give me some poetic license here. How do we fix things? Well, to try and understand the problem, W3C has run a series of workshops. We're continuing to run the workshops. I'll talk more about those in a moment. We've started a digital publishing activity. And we have a digital publishing interest group. This is currently member only. You have to be a W3C member or invited expert to participate. And the reason for that was that it was an incentive to get publishing companies to join W3C, and it has actually been working. Publishers are by no means the only people that are targeted by CSS for print, obviously, but they're one important group. And one reason for targeting them is that book production is moving to CSS, and I don't want crap books. Does anyone here want crap books? That sounds like one of those political statements, doesn't it? You know, the Facebook, you know, share this if you don't want crap books. Now you can't hear me at all. Sorry. Can you still hear me at the back? Do you want to hear me at the back? No, never mind, don't answer that one. I don't want to know. One of the workshops we held was in Paris last September, was specifically about workflow using the web and about going to print. And it was interesting to hear from, the proceedings are public, you can see them. It was interesting to hear from O'Reilly, who's using the Antenna House formatter and CSS. It was interesting to hear from Hachette, who's using prints. I get this wrong about half the time, actually. I get them the wrong way around. But Hachette is one of the big 6 publishers. They produce, I think it's 8,000 titles a year or something. So every year they're producing more than O'Reilly's ever produced, to put it in perspective, because O'Reilly is one of the most visible in our world. And they're doing, I think they're doing about 1,600 ebooks a year through prints and CSS. And that week of the workshop, 4 of the books in the New York Times bestseller list, 4 of the top 10 were done with prints, and 2, it happens, were done with Antenna House, with CSS. That's 6. I believe all or most of the others were done with XSLFO, by the way. And to the person, whoever tweeted about you don't want poor quality books, I'll note that you actually, in the Antenna House case, it's the same renderer, right? So I will explain in a minute what I mean by crap, but what I don't mean is poor rendering quality from professional quality rendering engines using CSS. Actually, it's getting pretty good. Okay. So XSLFO people, this diagram, yes, it fitted, good. This diagram is not unfamiliar to you. partly because I stole it from the W3C website for XSLFO, but then I put it there in the first place, so I kind of feel justified. You take your input documents, you go through XSLT to XSLFO, and you produce PDF with a renderer of some kind, right? But we want to format, well, maybe we don't want to. Some of us want to format XML with CSS and get comparable output. We want to do this. We want to take arbitrary XML and a CSS renderer and produce beautiful output. Note that a CSS renderer does not have to be a web browser. I'm not expecting right now a web browser to produce book quality output, which is just as well, because if I was, you'd say I was on crack. And although the convenience store next to my hotel sells marijuana drinks, it doesn't seem to sell crack drinks. Actually, I didn't ask. CSS is meant for styling HTML, though, and there's a whole bunch of semantics in it that get really confusing if you try and apply it to general XML. You quickly get on your own. These days, it can almost do namespaces, but there's a lot of limits. So our goal of arbitrary XML instance through CSS to PDF, we have to rein back a bit and say, let's say XHTML or maybe even HTML5. Has anyone here heard of HTML5? One person near the back. He's editing it. All right. But there's some limits. Big one is that CSS can't reorder content. It's not entirely true, and as of this week with or last week with the CSS, the oddly named CSS regions spec. I say oddly named because after lots of discussion internally, what it's got left in it is named flows. So the CSS named flows spec called regions has just gone forward. And there is some reordering of content in the generated content and paged media module. But CSS is not good at reordering content. It doesn't have transformation built in. When you use HTML, you're stuck with browser-centric markup. We've seen various, at this conference, we've seen various attempts to change that, to get around it, and with more or less success. But the way of thinking is about what will the browser do with this. We saw this right at the start of the conference with the ability to add your own elements with web components. But the first question is, what can they do? We add behavior. What does the browser do with this? Not what information is being modeled. HTML did come from tech publishing, so it's not impossible. I've said that. But in practice, what we do is we do a transformation. So we take our input documents and maybe we do an XSLT transformation into XHTML, and then we apply a CSS renderer and get our beautiful output. And if we do that, we can do things like a table of contents. Okay, I'm going to, before you try and read that, I'll take it away. I'm going to give you a few examples of things in CSS to give you a feeling for some of the differences between formatting with FO and formatting with CSS. And I found out at lunch there's an error on one of my slides, so someone will spot it, I hope. The prize is a free glass of water. So, XSLFO is an XML vocabulary that uses CSS properties. So you say things like block, or almost all the examples say FO:block. I think this was done deliberately to try and frighten HTML people away from XSLFO. There's nothing to stop you declaring the default namespace on the top and just saying block. So I do that. Block font size equals 12 point plus 1 millimeter. That's a perfectly reasonable thing to do in XSLFO. My goodness, I'm going slowly, aren't I? CSS has values, not expressions. That's the first thing you'll run into, and you use calc to get your expressions back. But the other thing is, instead of putting the CSS onto the element it applies to, you use selectors to join them. And CSS style rules cascade so that all applicable rules are merged and later ones override earlier ones. And CSS, of course, does not have page templates. So all the content comes from the document. What this means in practice is in your XSLT transform, you put a whole lot of stuff in there that you then take out again with CSS and use in various places around the page. Okay. So here is a formatted book. This was not done with CSS. Formatting a book. When you're formatting a book, the first thing you do is you think about pages, and then you go down to the text level. Then you go down to how do the pages interact with each other, spreads. At some point you talk about binding and finishing, distribution, and metadata. W3C is having a metadata workshop in April of this year. Metadata for publishing and annotations. How do you annotate web pages? How do you annotate ebooks and share that? Here is some CSS for defining a page. You can say page size A4, or you can give width and height, especially if it's not one of the about 6 built-in page types. Here's an example of generated content, so you can make a running header page and then refer to the page number counter in CSS. I've said that. You can have fixed content, position fixed in CSS. Roughly corresponds to static content in a page master and XSLFO. You can set strings in an element. You can say when we get to this element, set a string and use it. And you can also move an element complete with its structure out of the document flow and put it into a header or footer. So there is some reordering, and you can now get complex markup in headers and footers, and that is supported. I've tried it in Antenna House and Prints, for example, Prints XML. If you're doing a table of contents, though, you have to include it in the document. You can't generate that in CSS. And page numbers and dot leaders you have to do with CSS. I won't go over this, but if you're interested, the talk will presumably be linked from the conference slides. I'm going to be told I'm over in a moment. No? Okay. The good news, though, is that we do have a panel after this, so if the questions can continue in the panel, I think we'll be on topic. Not immediately after, but one. I used in the example I didn't go over here, I used a selector in the CSS at the top, which is quite a complicated thing. I should tell you about it. div.contents ul li a : after. CSS web people will go, eek, that's really inefficient. And you should put greater than signs in there to say immediate child of and use a subject indicator, but in fact you don't care when you're not doing a web page because the difference is measured in milliseconds. What you do care about is an error in those things is almost impossible to debug, and you'll spend a lot of time trying to figure it out. And the great thing about using XHTML is that there's this fabulous debugging tool. Has anyone here done inspect elements in Chromium or Chrome browser? I'll ask the other way around. It appears about half. Has anyone not seen it? Okay, no hands. All right. So if you generate HTML for print, you can look at it in a web browser. About a fifth of your CSS will be ignored by the web browser, and it will all come out crossed out because the web browser doesn't support paged media. But it doesn't matter because typically what you're trying to debug is things that it does support, and you can right-click and find out which selectors applied and why. And that is the most time-saving tool imaginable. And the neat thing of using HTML for doing your publishing is you get that benefit, that kind of network effect. And CSS style rules combine. It's different from XSLT, where a template is either used or not used. In CSS, different bits of a rule are used. The individual pairs get used or override others, and so only some of them get used. So that can be exciting. What am I doing? Okay. The numbers are meaningless on this. If you try and do a baseline grid, which is a fundamental thing for typesetting, you'll find you can't do it in CSS, and you'll go crazy. And that's a current area of work in the CSS working group. Indexes, similarly, you can't merge index entries in CSS. XSLFO does that in the formatter. If you're doing back-of-the-book indexes to any great extent, you'll want to use XSLFO, not CSS.
at least for the index and probably for the whole thing, to get the page numbers right. In the prints formatter, you may be able to do it in JavaScript, but there's no standard way of doing it. Actually, I need to skip this one because this is the one I found. The third point on this is actually incorrect, I think. But does anyone here know what those are? Does anyone here not know what those are? They're all gone to sleep. Those are pieces of type. Those are actually less than and greater than signs produced by a monotype machine. And CSS has support for open type features. You can turn open type features like historical ligatures, ranging, non-ranging table figures, small caps on and off. And that's supported. There is support for that. But there's a whole bunch of things that XSLFO does, CSS doesn't. So when I talk about books being crap, a lot of it is not, in fact, about the page rendering, which is getting really good in CSS. A lot of it is about things like complex tables and table headers repeating from table to table. It's about positioning of footnotes, whether you can have per column footnotes. It's about spanning between columns. It's really easy to get started with CSS, it turns out. The difficulty with FO is that you have to master XSLT, and you have to have quite a big understanding of FO before you can get Hello World working. Now, once you've got up that learning curve, you can do a lot more than you could with CSS. Right? But it's a learning curve. It's difficult. With CSS, you can take pretty much a plain text file, put a few tags in there, hope they more or less balance, add a CSS rule, and you end up with something awesome. Well, okay, maybe you don't, but you end up with something formatted. And the value of that should not be underestimated. Okay, I'm almost done here. I want to re-emphasize W3C process means the public has a huge voice. CSS gets talked about on the style mailing list, which is very busy, but if you send formal comments on any spec to that list in the way that the spec tells you to, they have a little piece of text you have to put in square brackets, or in some cases you can enter something in Bugzilla. It unfortunately varies based on which of the 60 specs you're commenting on. You do have a voice because it will be considered by the working group, and the spec can't go forward until it's resolved. And the good news is we do have people doing commercial book formatting and commercial print formatting with CSS in the working group now. And they are listened to. The working group goes quiet and listens when they speak, which is a huge step forward. So you can join, watch for announcements. Next workshop is in April, as I mentioned, on annotations. It's in the Bay Area in California, not the Prague Bay. Is there a Bay? Yeah, all right. I think that's all I needed to say, and I've got to 0, so apologies.
We do have time for one question. Anyone?
I've sent them all to sleep. Oh, yeah, this one.
Right here.
Well, just a small question. What I've always been missing in CSS is constants. Like constant.
I'm sorry, I'm having a hard time hearing you. Can you speak slowly or into the microphone?
Okay. What I've always been missing in CSS is things like constants. A constant for specifying the font height, a constant for specifying some width or the name of the font.
I think what you're saying is you've missed constants. Like you want to be able to say page width or left margin is 1 inch. And then add left margin to an offset. And you can do that now using custom properties. So for example, in the selector for :root, which selects the top of the document, you can say var-page-width, :9 inches. And you can go and get at that with var open paren page width, close paren, and you can use that in calc for an expression. It's too new to expect it to be implemented, but it took me about an hour to implement it in XSLT, in fact. I pre-processed my CSS with XSLT and implement that so that when the implementation that I'm using supports it, I can just turn that off in my XSLT and use it natively. And sorry.
Is it less than SAS or preprocess?
Yes, there are other preprocessors for CSS which do it as well. I prefer not to use a preprocessor if I can help it, because then when I try and open the thing in the browser to understand it, I find my CSS has been transformed into something I no longer understand. So, okay.
Thank you. Sorry about that. Right, if there's any more questions, just queue them up for the panel we'll have. Right, thank you, Liam. Next, we have Tony Graham, who will be giving his view of formatting in XML and XSLFo, I believe.
He's going to say everything I've said was wrong, right?
And then we're going to have a knife fight during the debate.
Yeah.
I hope so. Should be there. Sure, it's, yep, there you go. Great. So to continue Liam's theme, friends, Romans, countrymen, lend me your ears. I come to bury Caesar, not to praise him. The evil that men do live after them, the good is oft interred with their bones. So let it be with Caesar. The noble Brutus hath told you Caesar was ambitious. If it were so, it was a grievous fault, and grievously hath Caesar answered it. Here, under leave of Brutus and the rest, for Brutus is an honourable man, so are they all honourable men. Come I to speak at Caesar's funeral. I studied Julius Caesar in school, so it's a good thing I'm not here as an actor or as a author. We're here to talk about formatting from XML. So for the purposes of today, I've taken the XML for Julius Caesar and turned it into multiple formats so we can compare and contrast different approaches. From the TEI XML, we're going to show you PDF produced using FO, CSS, and also speed data, and also where it differs from produced using XHTML. So since we're talking about XML, this is the XML for Julius Caesar. Being TEI, it's very verbose and semantic more than your semantic HTML would be. So it's down the bottom here is the start of the text, hence home you idle, get you home. Here's the first page of Julius Caesar, the original, and formatted with XSLFo, and as it often happens, if I include vendor extensions, I get things like the column rule down the middle. By way of comparison, Patrick ran up one with Speed Data Publisher. So we can do reasonable facsimiles of Julius Caesar with a bit of extra work. We could probably get even closer. As Liam points out, we can do much the same thing with CSS. But, I mean, you're probably glazing over at this point. They all look like Julius Caesar. So we're going to narrow in a bit and use the example of how do we format an initial capital, or the so-called drop caps. I mean, back in 1624 or whatever it was, the printer would have got the big H and stuck it there, and he would have got the smaller letters and put them in, and it would have happened. If you're in the 1950s, you're trying to find out what to do, you'd buy a book and have several pages of examples on what to do. And again, it'd be a manual process. In the 80s, that's the start of computer typesetting, but still a fairly manual process. The designer would say exactly what to do. And to do this with cold metal, you'd have to take a chisel to the capital G to be able to get the text in that tightly. By the mid-90s, it's more of a boutique thing, and you think that typesetting and typography begins and ends with elements of typographical style. There's things here that even that we would find hard to do automatically. Things like optically aligning the V there so it juts out into the margin rather than leaving a big white space if it was indented into the margin, into the body of the text. But we're doing XML, so the first thing you think of with XML is XSLFO. So you go to the specs and you find in the draft for XSLFO 2.0 that we're defining properties for drop capitals to handle some of these things, some of the alignment, some of the moving the text around away from the drop capital, etc., which is very all well and good until you look a bit more closely and you look up the XPPL working group and you find that it's no longer active because of insufficient participation. It didn't have its charter renewed because there weren't enough people active in the thing. This first excerpt is from the previous charter, where the best that we thought we could find was we'd say we had to have a minimum of 6 people, and the sort of minimum we thought we could depend on people to do was 2 hours a week. If you contrast that with the current draft charter for the CSS working group, their minimum is 10 active participants, and their expectation that each of those will be funded to work 1 day a week on CSS at least. And their expectation is that their editors will be funded to work 2 days a week on that. So compare the resources available to the 2 working groups, which led, this is from a 2012 CSS face-to-face minutes, where the statement is that CSS is clearly and decisively won on the web. So in many respects, that's true, but this is from an email last year on the XSL list from an XSLFO vendor who quite confidently states that things are fine because he's done all these things and he knows that a lot of that was done with XSLFO. So it's not so much that XSLFO is dead, it's just not visible to the people. I mean, on the web, it's the developers who are sort of the kingmakers, and they say what's hot and what's not, but the FO vendors have gone and taken the toys and gone somewhere else. I was asked at lunch quite by accident, are there any FO vendors anymore? So I did a search on XSLFO, which is W3C's mailing list for XSLFO for last year, and I found exactly one. I'd actually done my homework before this. I wasn't going to put this slide in, and I looked on the websites of all the vendors that I knew of, and I found these these are the months in which these vendors have advertised new products on their own websites. So they're active, they're happy, but they're not visible to us and we're not visible to them. So if there's no working group, what's next? There's a community group, which I happen to be the chair of. It has that's the group description, and I was a bit remiss on Friday about advertising this, but anybody can join and you don't need to be an expert. So this is sort of the next best place for XSLFO. We did a survey just last month about what we should do, and it's interesting that the people outside the group thought the most important thing we should talk about was XSLFO. The most important thing we should do is develop a new specification. And the most important specification we could do would be XSLFO 2.0. This is people who sort of are projecting that there should be an XSLFO 2.0. But amongst the members that we have, we weren't so strong on focusing straight on XSLFO. We weren't so strong on developing specifications. And we weren't even strong on, if we do develop a specification, should it be XSLFO 2.0? Because as a community group, again, without the people tasked to work on it, we don't have the resources to push forward a complete specification. So, in the absence of an XSLFO 2.0, what can you do? You fall back to what you do with 1.1, which way you would make a float for the capital H. So this is some of the XSLT that produced the FO that made the page that you saw. And as you can see, I was able to float the H, and because I have XSLT, I can do what I like with the XML. I was able to make a nice capital E to more closely mimic the first folio. But floats aren't very good. Perhaps if we had a better specification that it was implemented, we'd be able to do drop caps by something other than faking the floats. So, FO, we will also look at doing the same thing with CSS. And in CSS 2.1, the technique is exactly the same, to make a float and float it across. And because the other interesting part about the text is the same as what you'd have to say about FO. As it says up there, it will span about so many lines. You don't have that much control over the presentation. So if I was going to, I'd try, this is formatting the TEI with CSS. I could do the float trick the same. I don't have a CSS selector that's going to get me that single letter out of the rest of the word. So I have a minor difference. It illustrates the difference in what you can do with the CSS selectors versus XPath. To make the HTML that I processed, I use the stock standard TI style sheets, which produces lots of divs. And I used the same CSS. When I printed it, it was very good because every speaker came out with a drop capital letter. It was like W's and T's and H's all through the page. So I had to modify my HTML to add an extra class so I could select on that. Potentially, if the formatter implemented something still very much a working draft in CSS, I could do better with selecting it, but I still don't have a mechanism for getting to my poor orphan E. So CSS post 2.1, just last week the WW style had another thread about there is no CSS3, it's just sort of this stop motion standard where specifications get produced. As Liam said, there's the digital publishing interest group, which is to provide requirements for other working groups. So we provide a forum for electronic journals, magazines, news, book publishing, authors, creators, publishers, news organizations, etc., which is very good. But as Liam also said, they're currently focusing on publishers. In email, I was told they're currently getting more publishers to join. The blog post from the interest group following their face-to-face at TPAC last year is that for the minute they've looked at their resources and set aside journals, magazines, poetry, children's picture books, comics and manga. So a large part of what was there has been deferred. Just 2 weeks ago, the question of what they should do about metadata, instead of expanding it to library things, they looked at their resources and said, let's do it amongst us publishers. The interest group has divided its work into multiple task forces. And the one that's the most interest to this formatting discussion is the Latin requirements, which is under active development. There's a guy called Dave Kramer from Hachette who's working on this. He takes comments and requests, and it has a section on drop capitals. It doesn't go into the level of detail of some of the books from 1948 or 1986, but I don't think we have the, I think it has so many other topics to do that spending that much time on just drop capitals would be sort of polishing the cannonballs or bike shedding in perhaps in modern standards terms. So the purpose of the Digital Publishing Interest Group is to produce notes which will be input to other working groups, specifically for the layout, the CSS working group. I tried to find in the CSS pantheon of standards and drafts where the actual sort of hint about doing the drop capitals would be. I couldn't find it. The standard that relates mostly to other aspects of pagination is the generated content for page media module, which covers things like headers and footers, etc. It sort of had a slow gestation, and in September last year the CSS working group decided to split that into a GCPM with some sections of it, and to put something else, the rest of it, into another spec called floats under the same author. And then this was done, a new editor's draft was made, and then the next week that author took his specs to the WG, and they became the books and figures drafts over there as living standards, or in one case a soon-to-be living standard. And since then, Dave Kramer, the author of the Latin rec, is now also the editor for the CSS version of the GCPM. So we have potentially dueling or incompatible specifications from the W3C and the WG about pagination as well. So I talked before about vendors and participation and resources. So you might be forgiven to thinking this is a slide from the FO side of things that I put in the wrong place, but this is a discussion from another CSS face-to-face about vendors and implementation, specifically about the pagination, the formatters. Things like we don't have direct access to the implementers. The lack of participation by the vendors is making it difficult. So the vendors of the pagination products that paginate CSS are similarly not participating in the CSS working group. It's, if anything, easier there because everything in the CSS is public, so you don't need to be a member to access the stuff. Another thing I'll point out, if you're on about XSLFO can sort of take back the ground from CSS, the W3C has put CSS as part of the open web platform, and rather than discussing technologies, they're putting out a questionnaire saying, how do you feel about when you use CSS? Not is CSS the best thing for the job, let's take that's not a question that's asked. It's what should we evoke from our audience? Should they be excited to use CSS? But I'm about to run out of time. These lines here are taken from a presentation by one of the inventors of CSS from a Paris workshop from the W3C. His view is it's not possible at this point to make books with standard CSS. It's not at the level of XSLFO, and adding this is going to take time. But with the CSS process and their levels, and as I've shown, the amount of participation they have a better chance of doing it than an XSLFO effort does. Dave Kramer, again, he has this wish list of things that before he joined all these working groups he wanted to see, and many of those sound like things you could do with FO and XSLT, but people are looking for them in the CSS context. So I need to finish. I don't really have a conclusion slide, so thank you for your time.
Right, we got time for any questions. Anybody have any questions for Tony?
Did I hear you say you have a conclusion slide?
Oh, no, I said I don't have it. Well, no.
I just got curious.
Oh, I have some more slides. Well, yeah, CSS.
What's a lookie?
Who said that? That's from the CSS charter again. Forgot I had these slides. CSS at this point has more properties than XSLFO does. And the last comment I had was something came up on the WW style thing about HTML. The CSS people are strong about elements who want to model only the elements, but at the same time, HTML is sometimes just a placeholder for pouring in stuff from JSON. So. No, I don't really have a conclusion.
Any other questions? Right, thank you, Tony. Thank you. And now could I ask Mike, Norman, Liam, and Tony, you can stay there actually. Is there anyone else? Alex?
Test, test. We have enough chairs. If you guys want to sit, you want to be in action poses, we can build a human pyramid. I mean, we got enough people. Yeah, well, no. Right. This part of the program, Liam's going to be leading a panel on publishing. So here you go.
All right. Well, you've heard two different talks. One talking about CSS and XSLFO. One talking about XSLFO and CSS. Two sides of the same coin, maybe. I don't know. Life is a shambles. So we thought we would have a panel after these two talks so that you could have a bit of open discussion and ask people questions. And I didn't prime the panelists particularly with specific questions so much as talk about scope. So the scope of this session might be really short, who knows. The scope of this session is formatting with CSS. When do you use FO? When do you use CSS? What's happening with what do you do with HTML5 and workflow? If you're going from XML to print via HTML5, does that work? Anything of that relation, anything of that kind. Maybe I'll just ask if there's any questions first and then go down the panel and let people speak after a moment. We do have some questions. Jonathan gets the mic first.
I know that O'Reilly is doing work where they're basically adding hierarchy from XML to HTML with section headers, and you know, the footnotes and some missing things. I'm wondering, in the future, how much of our work do you think is going to be done that way, using familiar HTML stuff for the stuff that HTML can represent in, say, DocBook, with additional stuff added where it doesn't work?
Maybe I should just, because I happen to know exactly what they're doing, I'll just expand a bit. The question is about O'Reilly's workflow and how long it will be before other people are doing the same kind of thing, I think. O'Reilly have taken a profile of HTML, so a subset of HTML5, which is restricted. There's good reasons for that, because it can be really hard to print an animated canvas element in a book. And they've extended it using data-star attributes to add the structure that they lost when they went away from DocBook. And they have an XML schema that authors have to validate against. It's actually done in the background, and they have tools to do it. That's what's going on. But I think the question is how long before other people do this kind of stuff. Anyone?
Is it on? Yes, it is on. It's about 11 different things I want to say. I'm going to stick to the positive, nice ones. I think that I think that is the future. I think that pragmatically what people are going to do is they're going to render to HTML or some flavor of HTML, and they're going to style it with JavaScript and CSS. Not the world I imagined we'd be in 20 years ago, but that's where we're going to be. And it'll be fine. We're all smart people, and we have fast processors. We'll make it all work. Authoring in HTML and using data attributes seems awfully fragile to me for capturing important semantics for your business, for your content, the stuff you really invested in. But people are going to do that too because it's easy and it's cheap, and that's what the authors want to do, et cetera. And it's probably marginally better than sticking it in Word documents. So, okay, I think that's where we're going.
Now, you made a distinction there that I want to be, an awful lot of stuff people write doesn't have any kind of business-specific data in it. If you write something in DocBook, I mean, DocBook is very generic in the same way that HTML is generic. I would assume that it's a lot harder to do a good job of HTML for custom vocabularies.
I'm not sure I understood that question. And I think I would dispute the generality claim between DocBook or TEI or something else and HTML. I think all of the vocabularies that have been developed, JATS, TEI, I'm not going to try and name them all, are all developed with a particular industry in mind, with a particular focus in mind, and provide better semantics for that category of information than HTML does. But I'm not going to argue that you can't impose the same semantics with class attributes and things if you're so inclined. It's just not the way I would choose to do it.
I think we're talking past each other, perhaps.
Perhaps.
Maybe
what O'Reilly did was not to try to put class attributes in for sections, but add section elements that look a lot like the DocBook section elements.
HTML5 does a better job for vanilla sort of booky things, or more things that look more like documents to me. I agree. I applaud the HTML5 folks for having moved in that direction.
Maybe worth noting that O'Reilly's authors also can use Markdown, for example, kind of wiki markup, and it's converted to HTML5 on the fly in the background. And their goal was to reduce the cost of the transformations. They were doing a lot of XSLT transformations into and out of DocBook. They had tens of thousands of lines of XSLT, probably hundreds of thousands actually. And they suddenly realized a lot of them they didn't need internally for their process if they started with HTML. Whether it makes sense for anyone else, I don't know. Michael.
If we're contemplating a world in which we're rendering to HTML, which for purposes of rendering appears to be then divs and spans with a few other things from time to time that get styled in various ways. That's okay. That's as easy for me to do as to go to F&O, which for me often boils down to divs and spans with styling. The question in my mind is, what's the current state of play with regard to multiple flows on a page? Base text, commentary, footnotes, parallel text, parallel columns, parallel facing pages. Where are we on that? I can't do quite what I want in some cases with F&O, but I can do more with F&O than I know how to do currently in CSS2. So any hope?
No, I can certainly speak for Antenna House, and we've got a new release coming out, 6.2, at the end of this month, and that's going to support multi-page footnotes, so you'll be able to pull footnotes across multiple pages, column balancing. Our goal has always been to increase the quality of the output, so you've got the flows, the anchors, all that functionality. You can certainly see a lot of that in the U.S. tax publications. If you go look there, where you'll see a lot of that deployed, and they've paid for a lot of that development work. We're also trying to make equivalent functionality on the CSS side of the product, but that follows the FO functionality. But eventually it'll get there, and it's all extensions. It's goes way beyond what the standard provides for. So with the FO, if you were to count up the extensions that we've added, it's over 200 now.
So speaking as a user of these tools right now, and having gone from XSLFO to some version of CSS, and I'm using Prince, and I'm looking forward to trying out their product, it's not good, the state of play, as a user. Specs don't, the implementations don't necessarily match the specs change. You go read the specifications, you find the feature you want in one of those 60 specifications, and then you're trying to figure out, does the vendor implement that? Oh no, they have a previous version, or they have an extension to do that. That's not a good position to be in as a user. Now, you might be able to get their product to do that, but it's going to take you looking at their documentation and talking to their technical support to try and figure out how to map their state of play to the standard state of play. And that's a really bad position to be in.
So for your application there with the multiple regions and the side-by-side and things, CSS has a region spec that they're working on and other specs. So at this point, CSS is going to make better progress, assuming, as Alex said, that they all implement it the same way than you find with FO at this point.
Okay, but it sounds as though the current state of play is not good, but it appears to be considered in scope rather than out of scope.
Yes.
Thank you.
Yeah, I mean, my problem with all of this is that we're expected to wait until CSS catches up rather than anything else. That's been my position for a while.
I'll just add to what the panelists have said and note that the CSS working group has, in the last couple of weeks, have moved forward a number of specs that include column footnotes we're not happy with yet in the GCPM draft, the new draft that Dave Kramer of Hachette has done. He's the new editor of that document. So the working group does not yet have consensus on how to do column footnotes, but we do have consensus that they have to be done. Multiple flows on the same page are there as of the CSS region spec, but synchronization between them is not there yet. There's not enough control over the synchronization yet, and that, again, that will come. But I don't know how long it's going to take. My gut feeling is a year or two, but I don't know, just because of the speed things are going at right now and the business needs of people needing this. But who knows? Famous last words.
But that slide that I had from the CSS about the vendor participation, part of that was the co-chairs of the CSS working group sort of saying they don't get enough involvement from the vendors for implementing these things.
Mike.
I'd like to sort of ask about the state of standardization in this field in the context of more general questions about what gets standardized and what doesn't, and the business models for standardization. We sometimes talk as if, people who don't participate in standards activities are somehow sort of morally decrepit. And I think what we need to understand is what's the social and business dynamics of the situation that causes us to get into this situation, where there's clearly a lot of motivation from users and from suppliers to develop better products. Why do we get into the situation? Is it perhaps that as I've seen sometimes in the database field, where people are finding their business interests are to move away from standards and to develop proprietary extensions, or is it some other factor in this field that ultimately it comes more down to vendors than to users. Users always want standards. Vendors sometimes want standards, sometimes they don't, depending on the business dynamics and the competitive situation and so on. So what's the nature of this business that has caused a slowdown in standards activity?
Let me answer from a vendor point of view. I don't know how many of you use Antenna House, but we've got several thousand customers out there and lots of licenses. We've had our product out there for 10 years. We've essentially got 3 key developers on our formatting engines. And those would be the same people we'd have to devote to the standards. A developer spends about 60–70% of his time doing bug fixes on released versions and the balance of his time on new development. So if I had to take from those 3 people and then contribute a significant part 1 day a week, 2 days a week to standards, it just becomes a real overhead that we just don't have the resources to afford. So, we follow the standards, we try very closely to implement them, we listen to our customers' requirements for products, but that's where we're at on that. We just don't have enough people to dedicate significant resource to spending days a week on standards work. It's a sad state of affairs, but that's what it is. Bigger companies have deeper pockets and can do it.
Anyone else on the panel? Norm?
I'm not a vendor.
Yes, you are.
I don't have an answer for that one. I'm not a vendor. I'm not doing that kind of thing. The overhead of doing standards is certainly high. I can appreciate that.
Well, from what I can see of the vendors, some of them have sort of morphed into products that handle customized output, sort of personalized mailings and things, rather than providing a general purpose XSL formatter. They've sort of got niche markets that they do. They don't advertise themselves as FO vendors. They advertise themselves as, we do this, we use the standard, so you can use FO to do the styling. So it's, as you said, I think that the vendors can wander off to greener pastures where they can make their money.
I don't have to, but I'm going to. The lack of good open source print, technology is a real problem, and that also is an issue. It's not just a business thing. Like the developers out there who want to do that, aren't there as much as they should be. And there's some, but a Wheezy print thing was kind of cool for a while, but it doesn't do enough. You can't really use it in to do good page media. So, and I don't have time to do it, unfortunately.
It's true that, for example, at a CSS face-to-face, you get maybe 40 people today, and CSS development has sped up hugely, while XSLFO development has slowed down. But part of that is web browser development, and web development is exciting. They're all hyper. They're all 6 years old.
famously some in their behavior, but who am I to judge? I'm only 5 myself. So there's this huge dynamic energy because things move in web development, and it gives this huge dynamism and huge excitement. And when it comes to print, traditionally publishers have had, all the way back to Gutenberg, publishers have used technology that other people have largely developed. They've improved it, but they've used other people's development and have not been pushing technological leads and standardization. And over again, when we approach publishers, they'll say, well, you just standardize something and we'll use it, and it will either meet our needs or it won't, but we'll try and use it. Which is a very different mentality from going to a bank, say, and saying, well, are you happy with the web? And they say, no, how do we change it? Even maybe bank's not a good idea, a good example, actually, but a web design agency, though, versus a print design agency, the attitudes are very different towards the technologies. I don't actually see how to change that strongly, but we are changing it a little bit by getting... The thing that has happened in publishing is that publishers have woken up to the fact that the publishers who have technologists in-house making ebooks are the ones most likely to survive, and the ones who are sending their ebooks to India and getting back PDFs, sometimes quite good, and sometimes of a quality that gets them banned from Amazon within a few days. Which it does happen. Those publishers are not surviving. And we're seeing the large publishers bring that work back in-house. Pearson has just announced they're doing it recently. They're doing in-house experiments, for example, and they had, for their work at, and they're one of well, they're the largest pretty much in the publishing world. I say pretty much because they keep buying each other. It's hard to keep track, but they're more than $10 billion a year, huge. And they've taken this technology in-house. But they're not W3C members today, although Hachette and Bloomberg, who are two others of that order of magnitude size, they are members.
I think it's also worth observing that writing a good quality formatter for printed pages is a ferociously difficult thing to do. The human eye is remarkably acute at the tiniest little differences, and getting a page that really looks good is an extraordinarily difficult task. And the requirements beyond being able to do a novel, which isn't that challenging, I think when you get beyond that stage, the requirements become more and more diverse. So the sorts of things that Michael wants to do with layouts that are kept in parallel and have various regions and things is just a really, really hard problem. And so it's difficult to spec correctly, and it's an investment of significant energy to code correctly. And so it's just hard. Harder than lots of other problems, even though all of us grow up reading books and not thinking perhaps that it's as difficult as it actually is.
Well, yeah, about the headers and footers, the CSS, the best you can do is put 16 strings around the edge of the page. And the Paris presentation from Dave Kramer that I referred to, he talked about as difficult. He had author's name, a little dingbat, and the book title in his header, and it was difficult because one of them was in italics and one of them wasn't, and he had to use up 3 of his 16 strings to do that. But say the S1000D standard for aircraft maintenance, there's a specification of I think it's 6 or 8 things you need to put in the footer of every page about applicability and all the rest of it. But I haven't seen anything in the CSS activity saying they want to do more than their 16 strings. They seem happy with 16 strings.
Tony, had he been using Antenna House instead of Prince, he would have been able to use the element open paren, close paren, which I mentioned in my talk, which lets you take an arbitrary element, and it is a standard part of CSS. It's not a vendor extension. It lets you take a marked up formatted element and put it into one of those 16 areas. So in fact, he would not have had that problem had he been using. It just happens that Prince and Antenna House each have different amounts of CSS implemented. But it is possible. I admit I only discovered it recently.
Right, because Bert Boss in his list of things shows mathematics in headers of journal articles and says that's not really possible.
Yep, it is possible, and I've done it.
It's just not obvious. And a lot of this thing about, it's the same with web design, right? It's like getting a border around a div in HTML that survives changing the size of the browser. Getting an image border. Originally, people did all sorts of different techniques, and people said it's not possible. And then along comes the barn door technique, which a whole bunch of people invented separately, including me, actually, but only because I didn't bother going to do enough research. And now CSS has an image border function where you give tileable images to make a resizable border. But you could do it if you were ingenious enough before. There's a whole bunch of stuff like that that people can do with great ingenuity. And heck, if you go back to 1475, I think it is, 1476, the first use of printers' flowers rotated in. Someone said, "What if we rotate if we rotate these little ornaments, we can get a really neat pattern for a border?" And they did it. Right, but it's a question of finding inventive ways of using the technology. So some of it is disseminating how to do stuff and learning and finding some kind of forum where we can share how the heck do you do put mathematics in the running header.
I guess, I mean, the fact that you have to be remarkably clever and discover these truly Baroque sorts of things to make what appear to be simple requirements work is one of the frustrating things. As somebody who is attempting to write style sheets for other people to publish with, working out what markup to produce to make it work is a challenge. And the fact that some things require 4 extra levels of div and span is just remarkably frustrating.
My attitude is you can only do this and keep any sanity at all if you decide that your HTML is an intermediate format, just like the FO was, and that you generate it. If you try and do print with HTML without generating it, then yes, you'll end up with 20 div elements that you shouldn't need. To format .leaders, then you add a span class equals leader and a span class equals page in order to be able to color them differently. Yes, it's crazy.
Yeah, and it still doesn't work because the dots didn't line up, but never mind.
I didn't do that with FO. I didn't do it with CSS, I mean, sorry. But you're right, they line up in prints and not antenna house right now. There's a property to say where they should line up. Do you have a question? Or are you asking for the microphone?
In this particular regard, XProc is your friend. I use it extensively, and I have a multi-stage process where I produce actually not one HTML, but several HTML flavors along the way, and they get enhanced until the very end, and then I run that through the formatter. And that actually works quite well.
Okay, any other questions? It's gone quiet. They're exhausted of all this HTML stuff. Let's get back to XML and coffee, right? Thank you, everyone.
Yes, thank you, Mike, Norm, Tony, Alex, and Liam. We're just going to have the XML London announcement now that I found Charles, so. And then you can refuel on some caffeine. Charles Foster, speaking about sister conference, XML London.
Thanks very much, Jim. So yeah, I just wanted to announce XML London 2014. We had the first XML London conference last year. It was really successful, had some really great speakers, and the delegates were very pleased. We're holding it again, of course, this year. It's going to be a yearly event. It's being held at the same location in central London. The price is £199 plus VAT for an early bird ticket. For that, you get the lunches, teas, coffees, the social dinner, the demo jam, conference proceedings, and so on and so forth. Call for papers is still open. I think that's closing at March 10th. And call for sponsors is also open if anyone's thinking about sponsoring the conference. So yeah, thanks, Jim. Oh, June 7th.
So you've gone for the warm option, I see. Well, it's warm in Prague this year. Thank you, Charles. One last thing before we go. We have this mysterious xproc hash Twitter tag with magic Czech liquor attached to it. Over the past couple of days, you may have seen some tweets with xproc attached to it. We'll be announcing the winner of the best xproc related tweet. So you have approximately half an hour to get one out yourself if you haven't done so already. Thank you. Enjoy the coffee. Come back in 30 minutes, please. Yes, nice. Thank you, Mohammed. Thank you. Right, welcome back for our last formal talk. Just before that, we're going to give away a lovely bottle of Bekarovka with a utensil for immediate usage. We decided that the idea of using the XProc tag would basically be your ticket in, so we randomized and we came up with a winner. Unfortunately, the winner's name is very difficult to say, so I'm going to mangle it, so I apologize. So, Yastin, please come down. Thank you very much. You actually tweeted quite a number of interesting comments about the requirements doc. And basically, this is a cheap trick to get people to read the XProc new requirements documentation. And you know, we'll probably give more of these away at some point. Thank you very much. Yeah. What's that? Yeah, drink. No, please don't. That stuff is quite lethal. But healthy, and serve it in the hospitals here. Right, our talk is about XProc, one of my favorite topics. And once again, I'm going to make up the pronunciation of this. Ari Nordstrom is going to give us Proxist, XProc processes in exist. Thank you very much.
Thank you. Is this still working, I hope? I can be heard. Okay, well, I'm going to talk about Proxist today. I'm going basically to do 2 or 3 things. First of all, I'm going to explain a bit what it is. Second, I'm going to do a demo. And third, I'm going to discuss why everything isn't there yet, sort of conclusion kind of thing. So, what is Proxist? Well, obviously it's the exist implementation of procs. That's not very helpful, is it? It's actually an XML-based abstraction layer around XProc pipelines. Rather than telling what it is, let me tell you why what it does, sort of thing. It attempts to describe processes, the processes around XProc pipelines formally. It's a definition language, simply. It's a relaxing schema. And if you think of a system, a document management system, and you have XML stored in there, and you process that XML, you publish it in various ways to print, web, whatever. You create reports, you analyze your XML, that sort of thing. All those things, to me, are processes. And all those processes can run one or more pipelines, in my case, XProc pipelines. And all of those pipelines can be configured in various ways. You can pass bindings into them. You can feed them with XSLT parameters, and obviously you can tell which XSLT to use, or which XSLTs. So it's a language that basically defines all this for a system. I tend to think of the main procs document as a blueprint, because if you have that system, you have a number of processes with this, and they all do different things. You could have something like a print process up there, or the web publishing process, and some kind of content validation and analysis process. Those are all of the processes this particular system is capable of doing right now, because that's what's defined. Now, every such process can then run one or more defined pipelines, and every one of those can be configured in a number of ways, because obviously you can't configure everything right away when writing this. So you have to let the user decide. And so the idea is basically this. The user, the end user, selects a process. I want to print publish something. I want to use the PDF generation pipeline, and I want to use something I call an informal internal template. It's just a layout thing with parameters and stuff set so the document looks informal. And what you get is an instance of this blueprint. This particular instance is fully configured to run this particular process, this particular pipeline, and this particular configuration, all selected by the user, okay? And the thing here is, why did I do this? Well, I showed this demo at Balisage last year. And what this thing is, it's an X form that takes the prox blueprint, the list with everything this system is allowed to do in terms of processing. And it displays the alternatives in this rather simple X form and allows the user to choose among the alternatives. And when done, the user will save this. And behind the system, scenes in the system, the instance that was created was then converted to a shell script. And that shell script ran the actual pipeline, ran the process. I call it the child process, because this is sort of a parent or a wrapper. Okay? And so this is what it did, and it did with some pain, because I mean it was ugly and it was still on a file system and everything was static. And so what I wanted to do was to put all this in exist and, you know, make it a bit more dynamic and a bit more refined. So Proxist, yes, it is an exist implementation of this prox thing. And I'll show you very shortly what it does. So I'm going to run a demo using this as input. And you still haven't seen any angle brackets, sorry about that. But this is a modularized XML document. It's a couple of sections linked to a root document. There's some subsections, there's some images, and that's it. Nothing very fancy, but when I want to publish this thing, when I want to process it, that's the root XML is what I point out. This is the one I want, and the system will have to figure out the rest. Okay? As for output, well, there's going to be HTML. There's going to be PDF, and then I'm going to define a new pipeline, new packages to use, and output that, well, hopefully. And because of the strange ways of the GNOME interface, I will turn my back to you every now and then, so I can see what's actually going on there, because it doesn't mirror the way I want it to. Hope it's okay. So, demo number 1, HTML. Let's see. Now, here's the exist interface. I've done this little web app. Whoops. And as you can see, there's an X form, sort of a little bit fancier than the last one at Balisage, not very much really. This thing here selects the input XML, and since there are quite a few documents here, I did a couple of filters to filter out stuff that I don't want to glance over. So I pointed out the root document, right? And the first thing whoops, this is more difficult than it looks. I generated what I call a resource map. It's just a big XML that lists all this XML, all the modules, but also the pipelines I want to use, the XSLT I want to use, the X queries, etc., everything. It's just a lookup file for lazy processing. I'll show you what it looks like very shortly. And by the way, the dialog is simply a means for me to not connect these two parts because I didn't really figure out how to do that properly. Here, as you can see, there's web print publishing, and if I click here, I can select other things. There's also a content validation option with a cross-reference check pipeline that I'm not going to show today. So let's run the web publishing thing. There aren't all that many configuration options because this is just a demo. So what I'll do now is to save the instance and run the conversion process. And ta-da! Impressive, isn't it? I know, converting to HTML is heavy stuff. Anyway, let me show a little bit about what it looks like behind the scenes. And this is far easier. First of all, let's have a look at the blueprint. I'll just double-click there. It's basically, there's a wrapper processes element. And as you can see, there are 3 process elements. I'm going to show the last one, the content validation, because it's basically shortest. First of all, there's some metadata. There's a title, and there's a description. And both title and description I use in the X form. So I just get them from this document and display them to the user. The description is a sort of a help text. Then there's a pipeline structure, and the actual pipeline definition here. Again, there's metadata because it's used by the X form. There's a link to the actual XProc script, and you'll notice that, I don't know if you can see this really well, but it's a URN, and the reason for that is simply that the system with which I created this is URN based, so everything has a URN when linking, and then we're converting those to URLs at runtime. Okay? So I just kept those because I need to process this thing anyway. Very reactive mouse. Sorry about that. It's an extremely reactive mouse. There's a type attribute here that says that it's a package. So different kinds of links in this system, basically. And this is a package kind of thing. It simply means that later there's a package structure, again, metadata, and a link to the actual file, in this case, an XProc. Going back up, there's a command line part that simply lists every available option that I want to allow the users to potentially change. So it doesn't have to be everything here in the blueprint, only the stuff that I want the user to be able to change. There's some inputs required by this XProc, such as the input here. It's external, it means that it's determined at runtime. It's not known when writing the blueprint. And there's a style sheet input, and it's known. And there are 2 options. This is the actual output. And there's a debugging thing. I don't know if this is used actually. I don't think so. But there's some problems with the Calabash module because it only accepts sequences, so I have some very ugly fixes in place right now. Looking at the resource map that is generated, let's see, well, it's basically a long list of resources, and you'll see that here are the URNs, and these are the current URLs. So I simply use this file to get data. Right. So going back to the, whoops, I don't know what happened there. Oh, there we are. So what happened here behind the scenes is that I generated a resource map, basically a big list of files. I got this prox instance, the document that describes this specific process. And then I used the instance, converted the instance. I did some manipulation to it to replace stuff with runtime values and that sort of thing, all from the resource map. And then I converted it to an X query and ran that X query and returned the results. So this one simply generates the list and selects the input. And here I use the blueprint to give the process, give the user the options to choose from. And this one basically saves the prox instance and runs an XProc, a wrapper XProc process that does all the rest. I'll show you in a second now. The save X query that initiates the process. First of all, it just saves the instance somewhere in a temp map. Then it runs this XProc that basically updates the prox instance with runtime values if missing, such as the target names. You want to name your target, you want to name your input, that sort of thing. Replaces URNs with URLs if necessary. Generates the X query that runs the actual child process. And, runs the process, returning the results. So if we look at what happened in exist, all this I did in this collection here. Here's the one that I actually used. This is basically an X query that runs the Calabash module using various bindings required. They're all described in the prox blueprint and selected by the users, unknowingly. And eventually this thing is run. Let's do another one, shall we? PDF is always exciting. And it's basically the same, really. Sorry. I'll have to do this and this. Demo generated the map. And PDF is already selected. It takes a few seconds, but it turned out okay. Ta-da! And again, this is just some very small child pipelines running, but they configured using this proxys thing. So if you look at what actually happened, what happened in addition to the last pipeline is that since the result return from the child process was FO, is an XML document using FO, I had to use renderx to generate the PDF using the X query. So it just checks what the root element is. Oh, this is faux, fine, I'll run it. And the reason for this is that right now the XSL formatter step doesn't work with the Calabash module for exist. For some reason there's something that doesn't work the way it's supposed to. Right. Well, let me show one last bit then, because these were all predefined processes. For all you know, I may have been up all night doing this, so perhaps it's very hard to do this. Well, all you have to do, if you have the, you do need to still write your pipelines and your XSLT and whatever you need, but once you've done that, all you have to do is to do this pipeline definition. In this case, I want to add it to the content validation process, not add another new process. I'm going to put it in the existing one. And I need to define the packages used by this pipeline. So let's do that. And this is probably going to be a bit painful again. Yep. I've prepared some stuff here. Here's a package document for the XProg I want to use. So let's copy that. You'll notice that I've prepared comments. Let's put it there. And you'll see that this is, again, it's just a link to the actual file, but there's an abstraction layer because I don't want to point at the file directly. For one thing, this thing allows me to group a number of related files and define them as a package. Let's get the here's a package that defines the XSLT. So let's paste it there as well. And all we need now is to insert the pipeline definition. And I've prepared one as well. It's by far the biggest, obviously. There's a pipeline definition, a link to the package, pipeline package. There's some metadata I want to appear in the X form. And all these are the defined input bindings. There's a normalizing style sheet here. Norm. So let's paste this. There we are. And save that and go back to where's the browser? Oh, running tools. Now, probably I might need to enter the cache here, but let's try this. Root. Prague. Oops, sorry. There. And there it is. And what this thing does is run another XProg to convert this to a mind map. And unfortunately, I can't open the mind map in the browser. Sorry, I don't know how to do that. But I think you get the point. I could actually download it, though. So, it was sort of simple. And by the way, I'm not saying that you have to write these by hand. If you don't want to, you can set up an oxygen environment, because obviously there are some things to remember, use IDs and stuff to identify the bindings and the values, and there's some tricks you have to do to identify the proper values and that sort of thing. Is all in the DTD, in the relaxing schema. And I don't really have the time to go into those now. But there is some future work to be done. First of all, the web app is still very crude, with all kinds of ugliness in the X query, in part because I'm a rubbish programmer, but also because I had to do some shortcuts because the Calabash module doesn't do everything I want it to. For instance, you'll notice that I couldn't actually feed any parameters to the child process. That's because right now feeding parameters via the module doesn't work. Documentation is very important. I can't hardly remember this thing myself. And this the XQuery wrapper, the save XQuery. Right now it checks the content of the XML that is returned to find out what kind of XML it is, and it's really ugly. And it shouldn't be necessary, because all that should be done by the child process. The wrapper XQuery shouldn't have to care about this. So I'd really like to go back to a more pure XProc here, because I've been forced to solve things using XQueries, and the parent XQuery doesn't have access to the resource map I generate, so it can't name the output files properly. Oh, well, I'm almost done, but huge thanks must go to Jim Fuller and Norm Walsh because of the work they've done. I certainly wouldn't stand here without them. And obviously the Wikibooks community for, well, giving me a non-programmer means to do some of this myself. And this is all on GitHub, so if you want to take a look, you can, and please do. But without the documentation, I sort of doubt that you'll be able to make this work easily. And with that, thank you for your time.
Right, we have time for a few questions. Anyone have a question? Question? Right, oh, right here.
Hello, very interesting. So you demoed several steps, well, several processes where you could provide an XML document as input. Can you also provide some other things like options or non-XML documents?
As input, you mean? I'm not sure what you mean there, actually. Could you?
Aren't some of your packages, there are images and other things?
Oh, right, yeah. You could actually provide anything the style sheet or whatever using them allows. So those are not parsed. They're just, they are defined as packages, and everything is basically allowed because I assume that the child process will be able to handle them, and it's up to the child process to do it.
Thanks.
Any other questions? Right, thank you very much, Ari. Thank you. And that brings us to the final chunk of time where we have Robin, who compels us to ask deep and meaningful questions. Do you want the hip mic or do you want the other mic? Ari, do you have the mic?
Yeah. Well, you didn't bring your own, did you?
So I hope everyone's had a deep think about what questions we can put to Robin. Right. Robin.
Hello. Can you hear me in the back? Yeah. Okay, well, welcome to this final session. I know you're all tired from, all this intellectual work in the evenings. But, this session is an audience session. I'm just here to make the stage look pretty. It's all about what you folks have to say. As you can see on the screen, and this is the only slide in this presentation, this year, 2014, is the web's 25th anniversary, and it also happens to be the W3C's 20th anniversary. So the idea is, in this session, to look forward, look backwards, take the time to think about what's happened in the web over the past 25 years, and what could happen over the next 25 years. I mean, 25 years sounds like a long time, but the past 25 years went by pretty quickly. I mean, I don't know how long it's been that you've been doing web tech or things related to web tech, but to me, it feels like it just flew by. So the idea is really that you raise your hand, maybe you want to say something about what you'd like the web to be fairly soon, and I'll try to, help more information come out, or you want to complain about something about the web, how the web is today, and, I'll also try to bring this into a discussion. So is there anyone who wants to start and jump in? Alex.
I tweeted this already, but basically what I would love to see is parity between what HTML can do and what we can do with arbitrary XML. We should have linking, we should have embedded media, and we should have scripting for everything, for all kinds of markup, but we don't. And there's zero technical reason why that is, other than lack of will.
Well, lack of will is a fairly strong reason.
Maybe. I would say it's lack of will of the vendors to do something about it. It's not, I could submit patches all day to WebKit, but they'll never see the light of day.
So well, there's one thing you can do, and I think I actually demoed this 2 or 3 years ago, which is that if you can import script into XML, served as XML on the web, if you use a script element in the XHTML namespace. And it imports script, it loads script. And then you can do whatever you want with the rest of your document. You can process it, and you could import components that would implement linking and everything else. I'm not saying it's perfect, but what? We're actually not that far, is what I'm saying, I guess. If you, kind of hold your nose like this. It's the web, it's not pretty. Yes?
Yeah, as you mentioned, namespaces. One complaint would be, you saw my demo last night, and I created TI head elements. Head in TI is what title is in DocBook. And this, despite it was in the TI namespace, was interpreted as an HTML head element. So I couldn't really create TI head elements in Saxon CE. And I think this should be possible to create a head element in another namespace.
So it would be possible. It actually normally is possible. It depends how that element enters the pipeline. So for instance, if you have a head element in the body of an HTML page, that is served as text/HTML, and so processed as HTML. then it will be taken to be an HTML head element. But normally, if you use create elements NS with the namespace, or if you serve the document as XML, and it's properly namespaced, then you should normally not get an HTML head element, but a TEI head element.
Yeah, it was created by Saxon CE. I think it was, so it wasn't served as anything, but it was created in the DOM. But maybe I should first file a bug with Saxon, so maybe it's their issue.
I suspect it's a Saxon bug. Or either that, or maybe you were using inner HTML, possibly? Or something in the stack when you feed it?
I don't think that the people at Saxonica ever thought about using inner HTML.
You never know, but maybe somewhere along the line, because you had quite a few components involved there. Notably, you had it's a CK editor that you repurposed, right?
Yeah.
I wouldn't be surprised if somewhere along the line something like inner HTML got invoked, and that would treat it as HTML.
Yeah, that may be the case. I'll try that without CK editor because they introduce some other issues. Yeah. Okay.
Yeah. And so in terms of editing, right now the editing situation is appalling for editing on the web. Content editable is terrible. It's almost unfixable, but this is a priority item that we would really like to fix soon. So if you have ideas for things that are missing in terms of editing, rich editing on the web, not just rich text, but rich structure and things like that, specific problems you had with that implementation or anything else, we're really interested in hearing back from that. Yes?
You're asking long term, and in the next 20 years, I won't be necessarily as agile on my web interaction as I am at the moment, which is not very heavy.
Bollocks, of course
but
you will be.
What I would love to see is the web being a much more difficult place for the charlatan. For the sorts of situation where, a very good example in the UK is if you go and do a search for UK passports, what you get these charlatans who come up higher, and basically they charge you for doing something that you can do entirely free at the official site. And it's just got to the stage where, unless you're really on the ball, then it's a place for charlatans. And what can we do to fix it?
So how do you see that working? Something like reputation management or some kind of web? Because
something of that of those sort of natures. I mean, it's tied up, but you've got certification at the bottom end. But it's something more than that. That when I'm dealing with some reputable agency, I'm actually dealing with that agency, not with some snake oil salesman who's inserted himself in the middle. Let alone malcontents or other miscreants who are actually going to want my credit card details to go off to Nigeria.
So, I mean, the problem is all the gray areas, because for anything that's obviously phishing, we have the safe browsing database that multiple browser vendors plug into, and there's this whole protocol where they actually hash the URL, send it to the safe browser with a bunch of fake hashes as well, so that you can't be tracked by the database. And they keep track of obvious phishing, and that's how the browsers do the phishing warnings. The problem is there's a very fine line between detecting phishing and censorship. There's a point at which some guy might not be actively phishing, but you might really disagree with his what he's trying to explain. And so the Safe Browser database has been very clear on sticking to what is obviously phishing and not stuff that's kind of borderline. So we can't use that for things that are in the gray area. We need a more some kind of reputation network, I would assume. So there was someone up there, and there was Mohammed here, and here, and here. Okay, John, go ahead.
So we had a little discussion last night, so it's worth bringing up here. What I would like to see in the future is an open, safe, and secure web. And to a certain extent, we've enjoyed that over the last 25 years. But I would like to see. I think we need to see measures taken to ensure that continues. So we talked about distributed DNS, for instance, to avoid man-in-the-middle attacks and censorship and things like that. But it seems like there's definitely some technological advances that need to be brought in to ensure that in the future.
Definitely, and for anyone who's interested in that, it's a very interesting topic. There is a workshop held jointly by W3C and the IETF in London next month. I don't have the exact dates in mind, but the idea is to basically take everyone from internet and web and put them in the room and figure out some kind of roadmap for making the web and the internet resilient to surveillance and state-level attacks. So yeah, distributed DNS is one of those things, preventing tracking, et cetera, et cetera. So there is going to be work. I have no idea what it would look like, though, to be honest. So hang on.
Hello.
I'm trying to hold a queue in my mind. 1, 2, 3, 4.
I'm one.
Yes, you're one.
Okay, hello. If I'm thinking about future, about safety web and about especially accessibility, I just like to ask you, can you imagine a web without JavaScript in the future?
No. To be honest, we've there is still some anti-JavaScript sentiment. I think it's time to let go of that because it's completely out of the box. There's no way of going without it. What we can do is every time we notice JavaScript being systematically used for the same tasks over and over again, then we boil those tasks into the platform. And that means that a number of websites can stop using JavaScript for those things. And this is an ongoing process. For instance, the DOM4, the current version of the DOM, adds a lot of things that jQuery exposes. And so we're still talking scripting because it's still the DOM, but it does simplify things. And again, in terms of HTML and the various options out there, for very common tasks or high-performance tasks or things that are accessibility sensitive, the idea is really to have things go into the platform. But the problem is, if we don't do it that way, if we don't let people do JavaScript first and then we standardize, then we tend to get things wrong. Because you create a complex declarative feature that is magical, and it actually turns out to be wrong. And this happened recently. If you look at app cache, which is the thing to bring a website offline, it was done as a high-level magical declarative feature, and it went horribly wrong. It's completely unusable. It's extremely complex to implement. Whereas there is now an effort called service workers to do the same thing in script and to give people the low-level primitives so that they can actually implement their own caching strategy. And I think that will be a lot more helpful. And after a few years of this, we'll go back to something declarative that actually matches what people want to do. But I really don't think we can get rid of JavaScript. I really don't think we should. It's our innovation vector.
Yeah. Thank you.
So we had 1, 2, and 3. Well, go ahead while the mic is batting.
Okay. Well, he has the mic, so go ahead.
Okay, go ahead.
Yeah, thank you. So, well, the security meeting in London is 2 to 7 March 2014, so it's just next month.
2 to 7?
Yes.
Okay. So it's very soon, yeah.
Very soon. Okay. Just wanted to jump about John's things about security and probably it seems like you're asking for more Facebook. So I'm just dubious about that. So
what?
because people can tend to recommend links between each other instead of passing through Google's and all this research that are hacked via CEO or things like that. So recommendation is probably interesting because it probably boils down to having some kind of distributed social network in order to be able to get into those things. But okay, just like that. Well, let me try to summarize those 25 years in 3 parts. 89 to 99 was for hackers that were hacking the web. From 1999 to 2001 was for business people using the bubble. 2001 to now is for who? To what you think? What's your thinking?
This is for everyone.
Do you really think that?
We need to get to the point where it is absolutely for everyone. I'm not saying we're there yet. Obviously, just the question of internet penetration is not completely solved. You can't have the web if you don't have the internet. But we're really getting there. Mobile is helping. A lot of people are discovering the web through mobile as their first device. And publishing is slowly but certainly becoming easier, et cetera, et cetera. So I do think that we're on the right track to make it for everyone, even if we're obviously not there yet.
So my point is, so you think everyone should be able to hack JavaScript into the browser?
It doesn't have to. So, well, yeah, no. You don't need to hack JavaScript to start publishing at a simple and fundamental level. You just need some CSS that you stole off the web and some HTML. You can go through tools. There are millions of CMSs. I don't think that everyone needs to hack the web. I just think that everyone should be able to publish to the web. And there are things that we can do to change the way it works. The current setup tends to encourage centralization, where if there's one really good publishing platform, one that's really easy for you, then everyone will tend to flock to that. So you find, I don't know what proportion of the blogs are spread between the 3 top blogging platforms, but it's fairly huge, and that's bad. And obviously people use Facebook and Twitter as publishing platforms, and those are heavily centralized. And we need to find a way of moving away from that so that people can keep their data. There are quite a few interesting projects in this area, things like Unhosted, that try to make it so that you can have your own storage and services can address your storage, and you keep your data, and you can have sort of web applications that interact with it and allow you to publish. There are people more on the semantic web side of things who are working on a similar project called Cross-Cloud. So the idea is really to move towards an architecture where you can keep your data and have good tools to publish without having to go to centralized, super cool, whatever's the latest cool publishing platform. So again, we're not there yet, but we're making progress towards an architecture that really enables everyone to publish. And by publish, I don't mean hacking JavaScript yourself, but having the tools you need to publish what you want to publish. So in the queue, we had...
So yeah, I think it's fair to assume that today one of the biggest driving force behind the web is web app development. Yesterday you insisted pretty much on the behavioral aspect of web components, and I think some people that I would say are pretty extremists see the future of the web as being using JavaScript as an assembly language to produce content for the canvas. Well, that's pretty extreme. But I think that there might be, well, do you think there is a divergence between the web as a platform for application development and the web as a platform for describing and publishing content?
No, I don't think. I think that's a false dichotomy. Yes, you will find people who want to do everything on the canvas, and if that becomes anywhere near mainstream, either of two things will happen. Either they'll realize that they're shooting themselves in the foot because they have all sorts of other problems, because implementing your own rendering engine is not fun, and because, accessibility, et cetera, or it turns out to be a good approach. And maybe hitting canvas directly, being hardware accelerated, whatever, it actually gives you performance that you couldn't get with HTML because you can throw away a lot of the crap that we've accumulated over 25 years. In which case, we will figure out solutions to make that useful for everyone. So we will figure out ways of making it accessible. We'll figure out ways of turning it, making it maintainable, etc. So one way or another, I don't think that we'll see any kind of divergence there.
Thanks.
Thank you. So we had...
Hello. Relates to a comment you made in answer to the question, can you envisage a web without JavaScript? No. But I wanted to ask the same sort of question in much broader and more abstract terms. In the history of computing, we've had three great monocultures. We've had the IBM mainframe, we've had the Windows platform, we've got the web. Those monocultures exist because of the economic benefits of doing the same as everyone else and being part of the community and the synergies that exist through de facto standardization. The previous two were a bit different from the current one in that the system of governance was rather different, the decision-making process was different. There were relationships between a vendor and its customers that led to a certain balance between stability and backwards compatibility versus innovation and ability to change. Those monocultures are extremely persistent. It's very hard to displace them because the cost of entry and of doing something different becomes increasingly higher. But the fact that we can't envisage the web changing to the extent of a programming language becoming obsolete in 25 years does seem rather worrying. And I do wonder how we get that kind of displacement and innovation in a culture that isn't driven by a commercial relationship between a supplier and its customers. We don't know what the motivation of the web browser vendors is, but it's not to make money out of us in the traditional way. We don't get a choice as consumers as to where we spend our money because we aren't spending it, it's all free. So I wonder how you see what is going to happen. Will it struggle on until it becomes technically so badly structured and incapable of refactoring at a software engineering level that someone else is going to invent something better and the innovators will switch and then everyone else will follow? Or will it collapse under its own weight? Or will it be capable of absorbing change and doing new things? What will be the dynamics of the web over that kind of extended period?
So obviously I can't predict, but here's my best.
Oh, you must. I asked you the question. Okay. I expect an answer.
So I will predict. I would like to separate two things when I said no to can you envision a web without JavaScript. There are two things. There's JavaScript, the language, the concrete language as we know it today, and there is the JavaScript, the extension point where you can just program things and hit APIs and manipulate the DOM. And I do think that it's possible that in 25 years we'll have JavaScript will have largely disappeared. It's entirely possible. But the functionality of being able to program the web in the way that JavaScript provides it, I think will stay. And the way in which it could be displaced is through JavaScript. That's kind of the sort of weird magic. When I say it's the innovation point, it's one of the major extensibility points. It really means that you could create a new language, implement it on top of the JavaScript VM, and start using it on the web. And if it really gains traction, so there are examples like TypeScript or CoffeeScript or a bunch of other hipster things. Sorry? XSLT2 is now running. No, but seriously, Frameless is a great example of this. If it turns out that that XSLT2 is really a much better language to do web applications, it could displace JavaScript, but the way in which it would displace JavaScript is through JavaScript, is by using the JavaScript VM. And after a while, if you start having 3% of the pages using this, 5% of the pages using this, it starts to make sense to implement it in the browser and start the motion towards displacement. So I think that one of the values of the web ecosystem as it is today is precisely that it enables innovation from within in a distributed fashion that can eventually succeed and displace stuff that we consider to be absolutely immovable.
Who's we?
We are the web developers. People hacking on the web. We the web. Does that address your question? Or?
Yes, I think the who is we is crucial. The decision-making process is very strange.
It is, well, it's, I would like to get at, so I didn't use those slides today, but in the previous version of my web components talk that I gave at Takeoff, which is much more web developers oriented, I showed the way that web standards are made today, where you basically have some vendor or person having an idea, bringing it to standards, then it goes back to implementation, and then by the time it reaches developers, it's too late for them to provide feedback and they don't know how to influence the process. And the idea of the Extensible Web Manifesto and this new movement that has taken over the TAG, the Technical Architecture Group, and a bunch of other places, is to try to make it so that you start with developers creating a new library and not caring about standards to start with. And as that becomes stable and popular, you move it towards the standards so that it can get inside implementations as a sedimented layer of innovation. This is something that succeeded, so let's make it actually a first-class citizen platform. So the idea is really to not have a decision process and to remove as much as possible browser vendors from the critical path to innovation, which again is not an anti-browser vendor position. It's something they tend to agree with because otherwise there's too much pressure on them as a choke point for new features. So if we manage to get there exposing primitives that allow people to innovate directly in script and then take those innovations and make them part of the platform when they've succeeded, I think we'll have a good mechanism for preservation, long-term preservation of the web.
Well, that's certainly a very fundamental shift of attitude from the one I was sensing sort of 3 or 4 years ago, where they definitely were a choke point. And
yes, things do get better, and
not always.
in this case, I have hope. And now I forgot the cue.
Can I, or is there someone else? All right. In the past 25 years, we've seen a myriad of standards, messy implementations of these standards, browser hacks to detect what kind of browser we're in, ECMAScript, JavaScript, and so on and so forth. It was a mess. Can we take the next 25 years to clean up that mess?
No, because a lot of the past 10 years has been occupied with cleaning up that mess. A lot of people still don't realize this, but so when people talk about HTML5, wow, bunch of brand new features, what actually goes into those blog posts and announcements, etc., is hey, you have video and you have audio and you have those new APIs. But for me, that's not the biggest value in HTML5. I could do without video. I almost never use it. But what's really, really fundamental is the increase in interoperability in the lower layers. So HTML5 defines a parsing algorithm that will turn any stream of text into something that's a predictable DOM. And this means that the mess in terms of parsing and different DOMs in different browsers is now a thing of the past. And it also defines a host of other basic behaviors, very low-level basic behaviors that have been cleaned up. It's definitely not finished. There's still a lot of work on encodings, on URL parsing, all the crappy low-level stuff that never worked is getting a lot better. So the whole mopping up work, much of which was done by the working group, is actually well advanced. So I don't think that we're going to spend the next 25 years cleaning it up. Most of it has been cleaned up. I think there's another good 10 years of cleaning up the last details. But it's one of those things where at this point I think we've cleaned up so much that things are actually good. And if you use recent browsers that implement the spec, of course. But the additional cleaning up that we can do has decreasing value, obviously, over time, since you're cleaning up smaller and smaller parts of the platform. But still, I don't think we're looking at 25 years of cleanup. Another decade at most.
Well, that sounds good. Only 10 years?
We won't even see it go by. So I think after there's John and...
I'd like to continue to argue about JavaScript, just because I hate it.
It's a lovely language. Try it again.
Yeah. Well, I don't believe in your idea that at some point JavaScript will be subverted by some of its successors with better features. Just because JavaScript is terrible. All of us know that, and all of us know how hard to write in it, and there is plenty of different attempts to make it at least suitable for some commercial use. And one of the examples of that attempts, jQuery. We have it for like, I don't know, 5 years already, right?
A bit more, yeah.
And it's everywhere. And it's used to make, well, I don't think that we currently have a JavaScript developer that can develop in JavaScript without jQuery.
No, that's not true.
Well, most of them. I mean, that's a good example of what we have already. Extremely widespread, but it's not in the, how do you call that, in the core, in the basement, and it never will be. So
yes, it will be. Of course it will be. I said so earlier. A lot of what jQuery adds, and I'm not talking about the parts that paper over old interop problems. I'm talking about the new APIs, have made their way into DOM 4 and will become, part of DOM 4. jQuery, one of the biggest parts of jQuery used to be its CSS selector engine, Sizzle, and that is now part of the platform as query selector. So they still have to ship it because all the browsers don't yet support that. But as browsers evolve, they're going to be able to just drop their own CSS selector engine and just call the browser system. It takes time, but pretty much all the good ideas found in jQuery are making their way to the platform. They're being baked into the platform directly.
Well, okay, I think that I'll wait another 25 years and see, will JavaScript as it looks now die, or won't it?
It won't die. JavaScript is Perl 6. That's why it's the best language ever. I'm serious. JavaScript really is Perl 6. That's why it's good.
I'm no longer programming in Fortran or in COBOL. And I wonder if we're coming to a different way of doing things as the web matures. We developed a lot of things. I was on the DOM 1 committee. And, I remember, with the XML working group and with DOM 1 and with XLT, there was this sense of we had to get things going because we didn't have anything that people could interoperate with. We had to create the standard and the technology at the same time. We had to do that in a very messy political process. It seems like, in some ways, the web is trying to fix itself, that things like AngularJS are trying to fix the problems that we have with JavaScript. And that a lot of this is not being done by standards groups. And that we're going to be facing a large number of different kinds of frameworks trying to address the same problems. And eventually the web will choose which ones. I don't know if that will be done by standards or by markets.
A bit of both.
But I doubt very much that we know to what extent JavaScript will be the language, or whether there's going to be a successor that fills in the holes for some kind of frameworks that, I think if we'd said that COBOL would almost not exist back 25 years ago, that would have been very hard to believe.
No, but again, as I said, I don't think that necessarily JavaScript as we know it will stay, but the same type of functionality, I think, will have to remain as an extension point. And in terms of the web fixing itself, that's exactly where we want to go. Standards should not make innovation; they should enable innovation. And it's when we get to the point where people can actually start fixing things without having to go through a standards process, it's a win. And afterwards we can figure out ways of bringing that back into the standards fold so that it's properly interoperable. I think that works better. John, so we have he was in the queue first, and then.
You hit on you pushed one of my buttons, which was JavaScript as the VM for the web. So I just wanted to kind of to plant a seed and wonder whether we can get somewhere with this, because I'm familiar with a number of different compilation techniques for different languages, interesting languages that work in different ways. And for instance, a lot of when we started compiling a lot of the languages 20 years ago, then it was commonplace to compile them into C and then to invoke the C compiler to compile those to the machine. And what you find is that for a lot of the interesting features that don't really match parity-wise with the underlying language, that's really quite restrictive, and you end up writing a lot of code to get around that. When people compile to the actual machine that's underneath it, they've got a whole lot more that's available to them in order to, do fancy things like continuations or whatever it might be. I mean, and so what I would really love to see is the JavaScript VM as a defined platform that you could write bytecode to. Because, for instance, when you look at something like Scala or F# that have been defined on top of other virtual machines, it wouldn't have been possible to write F# in terms of C#, at least not as efficiently as it currently is. It wouldn't have been possible to do the same for Scala on top of the Java virtual machine. And so I have to admit that I don't really believe in efficient replacement languages for JavaScript until we have some kind of definition of a virtual machine for the browser.
Well, so the thing is, I mean, I don't necessarily disagree, though. I don't see that happening in the short term. There isn't. I haven't seen much interest, but I don't think that. I mean, I think that new languages, any new language that might displace JavaScript will do so without being efficient at first. It will be popular for other reasons, and it will be sufficiently efficient to be usable because the underlying JavaScript VM is becoming insanely good. But it will provide incentive to actually support it directly in the platform in order to make it more efficient. But there have been proposals for JSVM bytecode, basically. So far, none of them have come anywhere near to flying. But it might be one of those things where people have to propose it for 5 years, and then everyone goes, "Oh, of course, why haven't we done that?" So I don't know. The problem also even with VMs is that VMs do constrain you anyway, even if you have bytecode, because it's not low-level machine bytecode. The JVM is not very good at a number of dynamic language features. If you try to do Python or Ruby on a JVM, it's fairly dreadful in terms of performance. So I don't know if it helps that much to expose a VM unless it has specific features, for F# of functional languages or whatever. I'm not sure how much it helps. It would be good to have benchmarks if someone were to do that. We had Jim and then I believe Norm. I can't see the whole room, so
Yeah, in the same sentence, you hit a button for me as well as John's, but it's a different button.
Hitting all those buttons.
It was the term innovation. I think in actuality, it's quite trendy to say software is eating the world today, and JavaScript is very important, and everything we do is very important. But actually, it's the hardware advances that represent the biggest shifts to what we're doing, and they precede each wave of what we see, at our level. Do you in your far and broad and wide-ranging experience and many conversations, do you see any hardware advances that is going to completely remove all our notions, and we're going to have to reconfigure how we consider ourselves as programmers, markup, and JavaScript?
So I don't know of upcoming hardware advances, but I know of two things that are hardware related and ought to make a sizable difference soon. One of them is generic access to hardware from a web context. Right now it's very ad hoc. You have to create a new API, expose it to all browsers, etc. It doesn't really work. If we can figure out a security model to expose any kind of new hardware using an HTTP interface or something like it, that's discoverable, etc., to the web page context, security, obviously, then we will see a new wave of innovation in hardware usage from the web. The other thing that I think is really important is that we're currently completely underusing our multi-core present. And it's not about the future thing. It's that, like, today, a typical browser rendering, well, the browser rendering is single-threaded. The processing is fairly complex in terms of event loops, etc. But if we could parallelize it more, we'd see an improvement in performance that would likely be staggering. So people like Mozilla currently has created a new language called Rust with its own runtime, and they're working on re-implementing a browser from scratch in a project called Servo. And that is designed to be able to make use of you know, a large number of cores at the same time. In addition to that, people are starting to think about what parts of CSS can properly be made asynchronous, what parts of, you know, the event model could be made more asynchronous. Right now, for instance, there was a really good talk by Paul Rouget recently, where he explained that scrolling on the web platform is synchronous. So any processing you do in reacting to a scroll event will actually stop scrolling because it's doing something else. It can't scroll. And that's obviously extremely painful. So we're really trying to, there's a lot of work trying to move towards something that's more parallelized. And once we get there, we'll see massive improvements, I'm fairly sure. I have no idea where we are in terms of queue. Either one of you.
Okay. So you can't push any of my buttons. I've been ground under by the process. They're all worn away. So you've outlined a plausible strategy, at least in broad terms, for moving from JavaScript to something better. Is there a similar strategy for moving from HTML to something better? Can I get my DocBook or TEI or DITA back on the web, or should I just accept failure and move on?
I think you should accept failure and move on. But within
grinding a little more, it's just lovely.
No, seriously, it depends on what you want out of using those formats on the web. If you want to render them, you can already do that. I mean, see, the CSS actually works today, and you can actually link these documents. You can actually link CSS into these documents, and it will work. It will render. I mean, I showed a magnificent example of DocBook here a few years ago. But in terms, the problem is in terms of behavior. How do you get them to behave? How do you get links to work? How do you get a bunch of other things to work? That's the harder problem. There is currently no link from anything XML to anything components-based that could actually lead to this sort of displacement. But it could be made. As I explained in my talk yesterday, the delta is very, very small. And we could imagine, I expect it would, I haven't tried this, and all of this is way too brand new technology, but I suspect that if you used a link element in the HTML namespace in your XML and used that to import a web component, it would actually work. And in working, well, there may be some technicalities, but it could be made to work. So we're definitely moving towards an idea, a situation where people can add elements to HTML. In terms of completely throwing everything away and replacing it, it may be asking a bit much in the current state of play, but I think we might get there. For me, the biggest impediments would mostly be about the decoration. So you might have to keep the HTML root elements, the HTML head, and then just dump some DocBook in the body. I don't know if that's acceptable to you in terms of transition, but it's a potential evolution. Of course, I'm not sure of the exact value of doing that for document-based formats, as opposed to things that might be more interactive. But you know, I think that there's a way forward. I'm not sure it's very clean at this point.
Okay, so JavaScript again.
Yeah.
Okay, if you say that JavaScript or another JVM similar language will be such a standard in the future. Do you think that if it's good that or cause developers are using JavaScript many times and very much, and they've forgotten that JavaScript is an optional choice in the browser, and I don't know if it's good to make standard from something what's optional.
So the thing is, I'm not convinced that JavaScript is optional anymore. Yes, you can turn it off in your browser in the same way that you can turn off CSS and a bunch of image loading.
Yes.
I'm not sure that you can do that and still expect the web to work.
Yes, but here in Czech Republic, for example, in hospitals, there is a globally JavaScript disabled.
That's bad system administration.
Yeah. Okay.
I can see the wrong reasons why they did that, but they really are wrong reasons. I mean, it's not the right thing to do. In terms of privacy, it's actually worse when you disable JavaScript. You're in such a minority that by just using the flag that you've disabled JavaScript plus your IP address uniquely identifies you in the world. It's perfect.
Okay, thank you.
Okay, so the question to the expert.
JavaScript.
No.
Oh, okay.
So the most of discussion is about what will be going on within the internet. So the question, do you think that there are any threats for the web from the outside? So what makes me think so? So we have several trends, like desktops replaced with laptops replaced with mobile computers, and probably following trends would be wearable computers, Internet of Things, and so on. Some of those devices probably won't be web-enabled, for example. And if we talk one additional trend from the traffic analysis, so for example on mobile devices, more traffic comes from special applications than from web applications. So actually we still have internet, we have REST services, but it's served by native application for mobile devices. So is that is web in danger or not?
There's always a threat of something better coming up. But I think in terms of applications, we're not seeing the end of the web that was predicted a few years ago by Wired and a bunch of other newspapers. It hasn't happened. And the reason for that is because nothing in that in the application ecosystem has some of the values of the web in terms of shareability and linkability. And it turns out that people actually use links a lot in social networking, for instance. So we haven't seen the displacement of the web, even on mobile devices, that has been predicted. Also, people tend to have those statistics for smartphones. But it turns out that even in the richest countries, smartphones are only 50% penetration, and the other half is feature phones. And those don't have those apps, and those use the web. And there was actually a really good article last year from Gov.uk talking about how all those government agencies always want to do cool apps because that's what cool people do, and they want to be cool and they want to be seen to be cool, etc. But they always say no unless there's a really good reason, because it turns out that when you do that, well, half the population can't access it, and what they see in terms of usage, people tend to have more return usage to a website that's been useful and that actually works for some kind of paperwork or anything than they would with an app. They don't know why, but that's the case. In terms of other potential displacement threats, like things like Internet of Things, it depends what you mean by web-enabled. Obviously, you know, a light bulb that supports, you know, one of the new Internet of Things thing doesn't have any screen to show HTML or whatever on. So in that sense, it's not web-enabled. But most of those devices are actually running HTTP. A lot of the networking that's going on is HTTP-based. And so you can, with a web page, address those devices directly, so you could have your web-enabled device talking to all of your Internet of Things over the web. So I don't, in terms of what I've seen happen in Internet of Things, I don't see a displacement. I actually see more of a reinforcement. And finally, if you look at things like Firefox OS and the new web-based operating systems, they're very impressive. I mean, if you look at Firefox OS, it's going to be if you look at it after the first year, it was already a usable operating system with applications and stuff and high-level graphics and running on phones and things like that. So they've done an impressive job. They're pushing really hard. They've only officially shipped in a small number of countries so far, but since they hit the, they're going for the $40 smartphone market, which is a very interesting market. And in countries where they shipped, I know that I think it was in Colombia, within a month they had 13% of the market. And they're going to be able to do, I think, to reproduce the same thing in a number of other countries. And those are purely web apps. So, you know, I think overall it looks pretty good. Who's Mohammed?
Yeah, me again. So I think I'm okay with this JavaScript things. Just I think we just have to let it go. So, but I think that it attracts a lot of people and as a honeypot, and they don't see what happened around. So it seems to be a problem. So first question is email. This is static document. We don't have JavaScript, and it's probably we won't have JavaScript in it. So how will we solve this problem? So it's open question. Second open question. It seems to be related to annotation and RDF and all this kind of thing. This is, can we think that the web will be more declarative in the next future than it is now? Because as I understand what you're saying is that today we're trying to make it more declarative by hacking in JavaScript. That's your way of seeing things. Mm-hmm. At the same time, we try to change low-level protocols. HTTP2 will be binary instead of being text, and it seems to be something that will change a lot of would say, base foundation of the web. You know, everything is open, everything is text, everything is hackable. JavaScript is text, CSS is text, HTML is text, so everything is good. But if we change the foundation and we make binary, how can we be sure that in the future everything will stay text on top of that, and that we are really going in this annotation style thing without too much binary or even worse than that?
So I think your two questions are related, and the second one is a troll, but you didn't notice it. In terms of email, there's a community group that was created recently called HTML, and the goal of that group is to define what is permissible and how it works to use HTML as an emailing format. The reason for that is that if you've ever tried to do HTML for email today, basically you're straight back to 96. You cannot import CSS, you cannot use any script, you have to do your layout with tables, you have to change your fonts with the font element. You can sometimes use the style attribute, but it's painful, you have to repeat it, etc. So the idea is really for that group to define a usable subset of HTML and a process that maps arbitrary HTML to a common limited HTML that can work for email, that can work in webmail clients and things like that. So we're really going to make progress on that. One thing that's interesting is that, so yeah, at this point, no one wants to have JavaScript in email. It's a fairly big no-no. But people are thinking of ways of adding interactivity anyway. And the way that happens is there's a proposal by Google, and I forget what it's called, but it's something that works in Gmail today. If you add certain types of metadata to your HTML email, it will take it into account. So I forget what the exact things are, but you can mark, I think it's using RDFa, you can mark up things as being a date for a meeting, and it will offer you the ability to save it into your calendar. And we're talking about, the ability of marking up something as an address, and it will provide you an affordance to see a map and maybe directions to go there. And I think that's interesting because it means that for email, for HTML email, we have to go declarative first, because no one wants to have script, even though, of course, it will be JavaScript in the webmail implementing the feature, but that's almost a side consideration. And so for email, we're going to see an increased use of metadata, declarative metadata, that adds limited, constrained, but useful functionality to email, where you don't want your email to be an application, but you do want it to have a bit more interactivity than the default thing. Now, to go to your other comment about binary and keeping things hackable, I don't think that switching to binary removes the hackability. If you look at email, it's a text format. It's a horrible, horrendous text format. It's unhackable. I mean, if you try to hack MIME, any kind of complex MIME by hand, you're going to kill yourself. Seriously, it's really bad. Whereas some binary formats, obviously you can't just load up a text editor, and even a hex editor tends to be painful. But if you have decent tooling, if the format is easy enough to understand, then you can interact with it. And we've had this debates on and on 10 years ago about binary XML and how it was supposed to make all of a sudden XML proprietary because it became binary, and I don't think that's true. If you have the proper tools to handle it, then it remains hackable. I mean, text itself, Unicode, is a binary format. And you really want to be dealing with the high-level code points through a tool called the text editor rather than with the low-level encoding, because if you start looking at surrogate points, you're not going to understand the text very well. So I don't think that HTTP2 moving to binary is a problem at all. I'm fairly sure we'll have excellent tooling to deal with it.
Well, it's just to finish about that. Is it because document, well, mail is more about document than the web is about document?
I think there was another, yes.
How do you see the role of databases for the web? How do you see the role of databases for the web and the future of the web?
So I'm not at all a database expert, but there's one trend that I've noticed recently. It used to be that we only had a few, well, it was a large few, but the set of databases that were available to people was relatively constant. And in recent years, we've seen an explosion of everyone and their dog has invented a new database system with slightly different properties. And those properties are interesting. The problem is it becomes really difficult to shop for the database you want because none of them has all the features. And you might think that one of them actually, that one of them matches your needs, and it turns out that it's not really well supported, etc. So what, at least at my level, from basic web developer level, what I would really like to see is some kind of Lego databases. So where I can pick some database components, put them together, and have something that matches my needs precisely, without having to care about all the rest, and without having to pick between a million different database systems. There's also another thing that I noticed that's interesting. I think it's ArangoDB does that. They have a very thin layer that is basically a web server that can serve static documents and nothing more, and can do authentication. And so basically with those two things, you can serve a web page and then authenticate, users can be authenticated if you need to, and you can address the database directly from your web page. So you can basically write an application entirely on the client side talking directly to the database, just using static file serving and authentication. I thought that was a pretty neat feature in terms of web development. It makes a lot of sense. But beyond that, I'm not at all an expert. I can't even understand what ACID means, but you know, I use JSON databases, so you'd expect that. I think we're done. Thank you very much.
Thank you.
I found this to be an interesting session. And many thanks to XML Prague. Awesome conference.
Thank you, Robin. It was very, very instructive. So just for the people that have forgotten, but this guy will be doing the HTML5 and XML melding fences in August. So I think I have to go to Balisage this year. So, so yes, we're going to close this conference, which was a very good conference this year. And we want to thank everyone that are still in the room, because a lot of people had left for logistic reason. I wanted to have a special thank for the sponsors, and especially the sponsors that are there for a long time. Now we can say that MarkLogic is a long-term sponsor, and Oxygen is probably the most long-term sponsor. We're happy also to see new faces in the sponsorship, like Basics, and especially Design Science, because they are really supportive of the XML community as a large, and the MathML community that seems to be something very important for all of us. So some other sponsors also were there, like Overstory and Mercator IT, that are trying to give us jobs. So it's a good idea anyway to be there. And also I wanted to mention that we have also some beer sponsors like Gerrit, who was the main sponsor yesterday for the dinner and demo jam. So yes, we are done. We want to say come again next year. And if you aren't able to come next year, then we have the video and things and stuff like that. The other thing is that you can also attend to our sister conference that have made a proposal today. And one thing, I think we also have to thank all our organizers there. And the last word to finish, if you have crazy ideas for next year, submit them. We accept any crazy idea.
Even some papers about XML, which seems crazy after this session.
Thank you.
Thank you.